Hello guys, welcome back to my channel based on African motives. Still working on O-level mathematics. In this platform, we shall be focusing on the question paper, which was actually written in November 2013, as we can see, paper 2. So we shall quickly rush through this and see what you're having. So remember your additional materials, the answer graph, the geometrical instruments, okay, the other paper actually, then the graph papers, we've got 3 sheets, the mathematical tables, the plain paper, which is 1 sheet. So make sure that you have everything. And also remember your instructions, which are very, very important, especially on your working. Remember, this is paper 2, guys. So this one is very important. Omission of essential working will result in loss of marks. And make sure that all your working must be clearly shown. So everything must be done properly, guys. And if the degree of accuracy is not specified in the answer, make sure that you're going to leave your answer in 2, 3 significant figures and at 1 decimal place if you are dealing with the degrees. So whenever you're dealing with degrees, which means you're dealing with angles, must give to 1 decimal place. Okay, so let us quickly rush through the questions, guys, that we are given so that we do not waste much time. We have got the first part of the question where we are given to simplify 15,6 minus 3 times 4,6. So there we are supposed to apply our BODMAS. I'm just going to shift a little bit here. So applying our BODMAS, we actually understand here that we've got brackets of division, multiplication, addition, then subtraction. So that means in this case, what we're going to do, we are going to multiply. We do not have brackets division, so we're going to multiply, then we subtract later on. So to multiply, you multiply the numbers which are multiplying each other here, the 3 and the 4,6. So which means we are going to have 15,6 here minus, then you multiply 3 times 4,6. So this is paper 2, guys. You can use your calculator direct on this one. 3 by 4,6. So that's what you're going to have, something like this, which is going to give us 16 over 9, 13,8. So it's going to be 13,8 here. All right, then we can subtract, since we are just left with 2 terms, so you can subtract 15,6, just direct, guys, 15,6 minus 13,8, like this. So you're going to have 1,8. So this is going to give us 1,8. So that was the first part of the question. Then the B part, express 8 over x plus 1 minus 3 as a single fraction in its simplest form. So that one is simplest form. 2 marks for that. Okay, so to express in simplest form, guys, as we know, we need to find the LCM of the given fractions. So this is our B here. We've got 8 over x plus 1 minus 3. So 3 is a whole number. As a fraction, it can be written as 3 over 1. So what are you going to do from this part? We are going to find the LCM or the LCD of the given denominators, which is x plus 1 and 1, which is going to give us x plus 1 here. We are supposed to have it like 1 into, but 1 times any number, just like 1 times x is x. So 1 times x plus 1 is x plus 1. Okay, so you can divide x plus 1 divide by x plus 1, that's 1. And whatever that you get, you multiply it to 8. So it's 1 times 8 minus x plus 1 divide by 1 here. So it's x plus 1, but whatever that you're going to get, you multiply with 3. So it's 3 into x plus 1 like this. Okay, so that means we can expand our brackets here by 1. 1 times 8, which is 8. Negative 3. Take note, guys, whenever you see a negative, take it with a pinch of salt. The negative one affects x here, and it also affects this one. That's our negative 3, I mean. So it's negative 3 by x, which is negative 3x, negative 3 by 1 here, which is negative 3, everything over x plus 1. So that's what you're going to have in this case. So we can simplify further, collecting like terms. We've got the 8 and the 3. So 8 minus 3, that is 5 minus 3x over x plus 1. So we can leave our answer like this. Since we do not have any common term in the numerator, sometimes you can be given a common term. When you have that condition, you factorize that common term. But in this case, guys, we do not have. So it's just going to be like that. We leave it like that. Okay, so let's cross-check the C part here. Solve the equation. This is 2p into whatever that you have. So we can just write this part here, guys, is the same. Like we can just cross multiply. Okay, these are just fractions. We can write this as a mixed, like as an improper fraction, so you can multiply here, then add. So this is 2/3, does not change. Okay, so this, I'm just going to write it here. So this part does not change, just write as it is, 2/3 into p plus 1 like this, which is equal to 2/5. Here we're going to get 10 plus 1, which is 11. So it's going to be 11/5. Okay, so that is what you're going to have. Then from this part, to remove these fractions, you can cross multiply. So cross multiplying here, take note that 5 here, this 2 here and the 5 affects each other. So it's going to be 2 times 5, which is 10. So it's 10 into p plus 1, which is equal to the 3 here, multiplies this side. So it's 3 times 11, which is 33. Then from there, we can expand the brackets since we've got brackets here. So the 10 is going to multiply everything. 10 times p, that's 10p. 10 times 1, which is 10, is equal to 33. So collect like terms, that means we can transpose the positive 10 to the right hand side. That means it's going to be a negative. So 10p is equivalent to 33 minus 10. 10p is equivalent to 33 minus 10, which is 23. Then we can divide by 10 both sides. That means we have got the value of p. So our p in this case is going to be 10 into 23, which is 2, remainder 3/10. All right, so that is what we are going to get as the value of p. All right, the D part, factorize. So now we are asked to factorize the given expression that we have. So guys, I'm just going to clear this part here just for this page. Okay, something like this. So let us have our D part factorized completely. So remember, when you are given 4 terms, we've got 1, 2, 3, 4 terms here. How do you factorize for 4 terms? You make sure that you have to group these terms, provided that you've got common terms. So here, we can collect the terms with x together since we've got ax here and we've got x. So we can just collect these terms with x together. So that means our D item 1 is going to be 2ax plus 4x. Then the terms with y together, we've got 3ay and 6y. So I'm going to have plus 3ay plus 6y like this. So that's what we're going to have, and it's going to make us easier. But if we have got common terms, then it's fine. We can just factorize like that. It does not have any effect. But here we can group now into 2. So by grouping into 2, that means I have to find the highest common factor between these 2 terms, 2ax and 4x. So we are going to have 2 is common throughout, and also x is common. So our highest common factor is 2x. So 2ax divided by 2x, that's a, plus 4x divided by 2x. So 4 divided by 2, that is 2x, and x will cancel. So we're going to have a plus 2. Then we move on here. We've got 3 is common versus 3 and 6 here. So plus 3, y is also common. So it's plus 3y. Then we can divide 3ay divided by 3y here. We're going to have a. As you can see, 3 and 3 will cancel. Y and y will cancel. You remain with a plus 6y divided by 3y here. 6 divided by 3, that is 2. Y and y, they will cancel each other. So we are going to remain with a plus 2. And also make sure that these brackets here are the same. A plus 2, a plus 2. If they are not the same, that means that is wrong. So you have to redo your factorization. Okay, anyways, they are the same. So I'm going to factor out this common bracket, which is a plus 2. So you take out that bracket, which is the same. When you remove this bracket here, you're going to remain with 2x. So it's going to be 2x here. And here you're going to remain with a plus 3y. Okay, so it's going to be plus 3y like that. So that is what you're going to have as your final answer. Okay, so that was the easier part, guys. Okay, item 2, factorize again. So here, do we have anything that is common? We can cross-check between, okay, let us just write our question, guys. It's 8x squared minus 18. Okay, so what do we have here that is common? We can cross-check between the numbers. We've got 4, we do not have no, so we've got 2. So you can factor out 2 here. That's 8 divided by 2, which is going to be 4x squared minus 18 divided by 2, which is 9. So we are done, but we can cross-check again. Do we have anything that we're going to apply? Yes, we have got difference of 2 squares. Why? These are perfect squares. 4 is make sure that each term is a square. So 4 is a square, x squared is a square, 9 is a square. So square root of 4, we know that this is 2, square root of 9 is 3. So which means they are perfect squares. So remember, one of the brackets is to take the square roots that we have, but adding, another one subtracting. So you just take any of the brackets, but one has to add, another one has to subtract. So square root of 4, that is 2, square root of x squared, which is x, plus square root of 9, which is 3, which is the same thing that you have here. You just subtract in the other bracket. So in this case, we'll be done. So that was the idea there, guys. We are going to continue on this part here. Okay, let me just remove this part here. Okay, so we're going to continue from this part, which is on item B. Okay, it's question 2 actually. So this one we're done. As you can see, guys, that's what we all had here. Everything is done here. All right. So on this part now, we are given that x is an odd number. Take note, the x that we are talking about is a number which is an odd number. And this odd number, find the possible values of x which satisfy, take note, they satisfy these two inequalities. And this x is an odd number. Actually, this is what you're supposed to do. These are two inequalities. So for you to know the odd numbers that you're going to have in between these two inequalities, you're supposed to solve these two inequalities, okay? So the first inequality is already in a solved method. We have a simplest format here. So we're just going to write as it is. So this is our 2a, x is greater than or equal to 3. Then from this inequality, we are supposed to solve and find a single solution, okay, on this part. So this is less than 35. So just like what you solve, what you do when you're solving equations, that's what you do when you're solving inequalities. So what am I going to do? I'm just going to transpose the negative 10 to the right-hand side, and it's going to be a positive. So 5x is less than 35 plus 10. Okay, so from this part, if you can add, we are going to obtain 45. So 5x is less than 45. In this case, we can divide by 5 both sides. All right, so our x is going to be less than 5 into 45, that is 9. You're in paper 2, you've got calculators, this and that. So guys, make sure that you do not lose some marks by just simple mistakes. Okay, this is what you're going to have, guys. Two inequalities of x. The one that is greater than 3 and the other one that is less than 9. These are the values of x that we're talking about. So you're going to combine them in this formatting of x is less than, or it can be whatever that we have, a less than or equal to b, depending with the inequalities that you're given. So this is the smallest number from the numbers that you're given, which means you're referring to this 3. So writing this, guys, take note, is 3, x is greater than 3. Of which you can write this way, x is greater than or equal to 3 like this. It's still one and the same thing here, okay? So it's going to be x is greater than or equal to 3. The same x that we're talking about here is less than 9. So this x is less than 9. So now you've combined your inequalities to say your x has to be taken from these numbers, from 3, but they are not going to reach 9 because our x is less than 9. There's no equal to here. I want you to see something. Let's say you're to represent this on a number line. It was going to look like this so that you can understand much better. This was going to be your 0 here, your 3, 4, whatever that you're going to have, 4, 5, 6 here, 7 here, 8 here, and 9. Okay, so I just started at 3. We were supposed to start at 1, 2, and whatever, but we just need these numbers here. So at 3 and at 9, but at 3 we're supposed to shed because it's greater than or equal to 3. So which means the 3 is involved here, but the 9 is not involved, so you're not going to shed. You just write it like that. Okay, this was supposed to be your number line of the values of x. So now you can see that 9 is not included because we just have a circle which is not shaded. So the values that we're talking about is 3 up to 8. So the values of x that we are talking about, x is a set of values from 3 up to 8, which means we're talking about 3, 4, 5, 6, 7, and 8. These are the values of x that we are talking about. But let us answer the question. The question did not say find the values of x. The question is, this x that we are talking about is an odd number. So that means we've got something to talk about here. from the odd numbers. What are we talking about from the odd numbers? We're talking about those numbers that when you just divide that number by 2, it leaves you, or it gives you a remainder of 1. Just take of 3. If you divide by 2, this is 1, remainder 1. That's an odd number. If it gives you a remainder of 1 like this, it's an odd number. So these are the numbers that we actually need from the solution set of X. So let us get to the solution set of X and pick the odd numbers, the ones that when we divide by 2, they give us a remainder of 1. So therefore, our X is equal to, we are now referring to the odd numbers now. So these are the odd numbers that we are going to take. So which odd numbers are we talking about? 3, if we divide by 2, this one is going to give us a remainder of 1. We move on to 5, we move on to 7. So now we have answered the question, because the question was referring to the X being an odd number. If they said X is an even number, which means we're going to refer to the even numbers, which means this time we're talking about numbers such as 4, 6, 8. So answer the question, guys, whenever you are in exam. Okay, so that was it, guys. Let us quickly rush to the other part, which is on item B. So I'm just going to clear this part, guys, so that we can have some space to write. B, we are given that f of x is given by x squared minus 2x plus k, where k is a constant, and f of minus 32 is equal to k. Okay, guys, I sent you recently a video on functions. So if you never watched that video, make sure that you watch it on functions, functional notation. I explained about functions. How do you simplify, like when they say f of 3 is equal to, what does this part mean? Okay, so remember, f of 3 means in place of x, you are substituting 3. That is what it means. So in place of x here, we are going to substitute 3. So it means we've got 3 squared. This is x squared, so it's 3 squared minus 2x, which is 2 times 3, plus k. This is not x, this is a constant, so it's just going to remain like that as a k. That is f of 3, what it means. So when you substitute 3, they are now saying the answer that you're going to obtain is negative 32. So you have substituted 3 in place of x, and your answer is going to be negative 32. So what have you formulated? Definitely, this is an equation, because we are given this is equal to this. So from the equation, now you can find this value of k, because the first question is for you to find the value of k. To find the value of k means you have to solve for k. Okay, so to solve for k, this is just a normal equation, guys. The way that you solve your equations, we can simplify here. So this was item B, if I'm not mistaken. Okay, so this was item B. Okay, so 3 squared, that is going to give us 9, minus 2 times 3, which is negative 6, plus k is equal to minus 32. 9 minus 6, that is 3. So 3 plus k is equal to minus 32. So this is a linear equation, guys. There's no need for you to take the minus 32 to this side, but you can transpose the 3 to the other side of the equation here, which is on the right side, and it's going to be a negative 3. So from this part, that means k is equal to minus 32 minus 3, and our k is going to be negative 35. So that is what it means. So take note, guys, this is the value of k that we are given, which is what? Negative 35. Then on that part, they are now saying hence. Guys, I told you about the word hence. Hence means continue from that, from the last part. Continue from the last part. That is what this part actually means. So which was the last part that we are talking about? We are talking about the last part where we calculate the value of k, which is the constant. We now have this k here. So we can rewrite our f of x like this. Before we solve this, we are going to rewrite our f of x. Remember, our f of x was given as x squared minus 2x plus k. Okay, guys, let me just wait a little bit for this to save. Okay, so we're given as minus 2x plus k. This was our f of x. Now we have the value of k. We calculated this value of k here. We got negative 35. So it means our f of x now can be written as f of x is equal to x squared minus 2x. In place of this k, I'm going to substitute the k that I'm having here, which is negative 35. So this is our f of x now. Currently, this is what you're going to work with. That is yes. So the question is, from this f of x that you have now obtained, solve for x for which f of x is equal to 0. So what does this part mean when they say f of x is equal to 0? Okay, this is your f of x that you have, this part. So we are saying this f of x that we have represented by this expression, it is now equal to 0. So it means we are now having x squared minus 2x minus 35 like this. Now it is equal to 0. So what are we given? It's now an equation, so you can solve for x. So to solve for x, it's up to you. I don't know which method are you going to apply, factorization, quadratic formula, depending with what you actually understand, okay? But using factorization, guys, I told you that whenever you are having the coefficient of x squared as 1 like this, you simply need two brackets that you're going to work with, equal to 0, put x here and x. So from these two brackets, you focus with the constant term, which is negative 35, okay? So you're going to focus with the constant, which is negative 35. Find the factors of negative 35. So you need the factors of this number. And these factors, if you add them, they must give you the middle number, which is negative 2. So what are the factors of negative 35? In this case, I've got these numbers, negative 7 and 5. If I multiply these two numbers, I get negative 35. If I add these numbers, I get negative 2. So this is what I'm trying to say, guys. Factors, negative 7 times 5 like this, I get negative 35. That's a factor. But if I add these two numbers like this, if I'm to add these two numbers, I'm going to obtain negative 2, which is this middle term that we see here. So which means these are the proper numbers that I'm going to use. So I'm going to have negative 7 here plus 5. This method is only applicable when the coefficient of x squared is 1. When it is not 1, use the longer way of factorizing, okay? So from this part, as you can see, guys, each of the brackets should be equal to 0. So x minus 7 is equal to 0, or x plus 5 is equal to 0. So what is the value of x? Minus 7 to the right-hand side is going to be a positive, or x is going to be plus 5 to the right-hand side is going to be a negative 5. So these are the possible values of x that you're going to obtain for this function to be equal to 0. That is what it actually means from this question. Okay. Now let us cross-check the C part. We are given that there are two. There is Albert here who can weed the garden in 4 hours. Okay. So that's a garden that he can weed in 4 hours, and we are given that his sister Baidi is what Baidi they take 6 hours. So to do the same job, that is what Albert is actually doing. Okay, so these guys, they have the same garden, but they have got different pace of doing the job. That is what it actually means here. So now we are given that if they decide to work together, assuming they maintain their working rates, which means they are still maintaining the same way that they were doing before, what is the fraction of the garden they can complete to weed the garden in 1 hour? Like how much, like in terms of time, what are they going to take to complete the whole garden together? Okay, so I want you to understand this question, guys. Let us take the Albert here, this guy Albert. Albert can actually take 4 hours, okay? So Albert is taking 4 hours to weed the garden. Then Baidi here is taking what? Is taking 6 hours to weed the same garden, which is his sister. So this is we are saying, if we are talking about an hour, we are referring to the complete garden, like a revolution. Just like let's just take a complete revolution. Okay, that is how you take this question. Like, so a garden, it's a complete revolution that we're talking about, and Albert is going to complete a complete revolution in 4 hours. Okay, what about in 1 hour? How many parts of this complete revolution has he completed? So it means we are going to have a lesser part, which means 1 over 4 times 1. So it's going to be 1 over 4 times 1, which is just 1 over 4 parts. So this one is going to cover up 1 over 4 parts of the garden, because we are referring to our garden as a complete revolution, like one revolution. We do the same part here to Baidi here. Baidi here is going to take 6 hours to complete the same revolution, which is the same garden. What about in an hour? How many parts of the garden is she going to complete? So it's going to be 1 over 6 by 1. 1 over 6 by 1 here, which is 1 over 6 parts. All right, so this one is going to complete 1 over 4 parts. This one is going to complete 1 over 6 parts. So this is in an hour time. We are now referring to the way that they are working in an hour time. So together now they are working together, which means it's a simultaneous way together, which means we are going to add them to say, if they are working on the same garden together now, what is that fraction that they are going to complete? So this one covered 1 over 4 parts of the garden plus this one, which is binding, is covered 1 over 6 parts of the garden. So now what are we going to have at the end, which is the total of the garden that they've covered in an hour. So we can work out, this is paper 2, guys. You can actually put in your calculator, simplify, or you can do the longer way, it's fine. 1 over 4 plus 1 over 6. This is going to give us 5 over 12. So it means they are going to cover 5 over 12 parts of the garden. So this is 5 over 12 of the garden, or because we are referring to the garden as a complete revolution. So they're going to get to cover 5 over 12 parts of the garden. Okay, so let's get back to this one. On item 2, the total time they can take to weed the whole garden. Okay, so take note, guys, in an hour, this was happening in what? In 1 hour. In 1 hour, this is what was happening. So now the question is, what time are they going to take to weed the whole garden together, working together? So we're going to compare from what they did in an hour, because we know that in an hour, these guys working together, they can complete 5 over 12 of the garden. So that's what we're going to take now. We are now saying in 1 hour, albeit and bind together, they are going to cover 5 over 12 parts of the garden. They're going to cover 5 over 12 parts of the garden. So now what is the total time they are going to take to weed the whole garden? What is it that they are going to take to weed the whole garden? So this is what we are simply having. The whole garden, it means it has got 12. This is what we're going to have, guys. In 1 hour, they cover 5 parts out of 12. So it means the whole garden has got 12 parts. Just like this, if you're given 1 over 4, it means it's 1 part out of 4 parts. So the denominator here means these are the complete parts of the garden. So in actual sense, we're supposed to write this as in an hour, they are going to cover 5 parts out of 12 parts, which is the whole garden. So the whole garden has got 12 parts. So in 12 parts, how many hours are they going to take to complete these 12 parts? That is what it simply means. Because we said 5 out of 12. So the 12 now is representing like the total of the garden. Okay, so this is what you're going to do using your simple proportion. You need to find the time here, so it's going to be less because they are working together. Actually, these guys. So you're going to have a more time because this is now like a complete garden that you're talking about. So it's going to be more. So it's going to be 12 over 5 multiplied by the time that we have here, which is 1 hour. So 12 over 5 is just the same as 12 over 5 hours, of which you can write this as a decimal. 5 into 12, that is 2 into 10, remainder 2, 5 into 20, which is 4. So it's going to be 4 hours. So together, they are going to take 2, 4 hours to complete the garden, or it can be 2 and 2 over 5 hours to complete the garden. That is the number of hours. We can write in hours and minutes. I don't know which one was best for you, but that was the idea for us to answer this typical question here. So we have got 3 marks for this, guys, and as you can see, it's actually clear. Let us move on to the other part of the question, which is question 3. On question 3, we are given that m is equal to 2p plus 1, n is p minus 2. Express mn in terms of p in simply. So this is, guys, this is just multiplication, guys. Mn simply means you're multiplying m and n. So this is mn. So we just have to take our m, which is our m is 2p plus 1. So that's what you're going to have. So this is going to be 2p plus 1 into n. Our n is p minus 2. But we can't leave our answer like this. We have to simplify further, expand brackets. So it's going to be 2p by p, which is 2p squared, 2p by negative 2, which is negative 4p. We are done with 2p. We move on to 1. So it's 1 times p which is P, 1 times -2, which is -2. Okay, so this is going to give us 2P squared. So we've got here, this is P, which is same as 1P. So we are now adding -4 plus 1, which is -3. So this is -3P minus 2. So this is your Mn. If we multiply these two terms in terms of P, that's what you're going to have at the end. All right, so I think this part was clear. Let us move on to the other part of B. On the B part, we are given in the diagram A, B, C is an isosceles triangle. So this is an isosceles triangle, meaning to say, okay, let me just clear this part since we are done on this one. So this means these two sides, they're actually the same of equal length, AB and what, and BC, they are the same here. So, and we are given them in terms of X, but these two, we are saying they're the same, which means they're equal. So, and we have got AC, which is 10. Form an equation in X and solve it. How can you form an equation? For you to form an equation, guys, you must have two equal things or two equal. I don't know what you're going to be working with, but you formulate according to what you're given. Here it's an isosceles triangle, and we are given that these two sides are equal. So that is where we are going to, already an equation is given here to say that AB is equal to what? Is equal to BC. That's an equation. So all you need is to take the AB. AB in terms of X is what? It's X plus 9, which is equal to BC in terms of X. BC in terms of X is what? Is 2X plus 5. These two, they're equal because if this is 10, this must be 10. So even if we are given in terms of X, it means these two, they are the same in terms of X. Okay, so here I'm just giving a reference to say maybe if it was 10 or whatever number that you have, it means they are the same. Okay, so we have formed an equation and we are not just forming, we have to solve that equation, which means we have to find X. Okay, so let us find X. We can transpose the 5 to the left-hand side is going to be a negative, so it's going to be 9 minus 5 is equal to 2X. The X here to the right-hand side is going to be a negative. Since it was a plus, so it's going to be minus X. So we can subtract 9 minus 5, which is 4, is equal to 2X minus X. This is same as 1X. So 2 minus 1, that's 1X, which is equal to X. So X is equal to 4. So that was the idea on this question. Okay, then on item 2, write down the length of BC. So we need the length of BC. So the length of BC, you just have to substitute here in place of X. Remember, our BC was given by, this is the expression for BC, which is 2X plus 5. So you can even substitute here, or because they are the same, or you can substitute on this one, 2 times X. Our X is 4, so it's going to be 2 times 4 plus 5. So 2 times 4, that is 8 plus 5, which is equal to 18. So that will be 13 centimeters. As you can see, even if you substitute here, 4 plus 5, that's 13. So it means you've got 13, you've got 13. Okay, so that was our BC, 13 centimeters. Then calculate the area of triangle ABC. So we've got triangle ABC. This is our triangle that we are given, and we need the area. Okay, so how do you calculate actually the area of an isosceles triangle? Okay, this is what you need to know from the isosceles triangle. Okay, let me just remove these parts. Maybe it can actually be clear. Remember, we have got the value of X that we have determined before. Now, this is what you're going to have. If we are to substitute here, I want you to see something from B to the base of the this triangle here, to the base like this. This line bisects this triangle. It's a bisector. So this one is got it's like actually a line of symmetry. So what it does, this bisector, it doesn't bisect only, but it also divides the base into two equal parts. So it is divided, it is a perpendicular bisector, and it divides this into two equal parts. So it means from this point to C is now equal from this point to A. Remember, it was 10 centimeters before from A to C. So you divide by 2, which is going to be 5. So this will be 5 here, and this will be 5. So what we need is actually the base is already there, but we have to find this height here, the perpendicular height. So like I said, it's going to be a perpendicular bisector. It divides into two equal parts at 90 degrees. So we are now having, remember we said this is 13, this is 5. So we have to calculate this height, which is the perpendicular height of the triangle. So using Pythagoras theorem, because it's a right angle triangle, remember your Pythagoras theorem, h squared is equal to a squared plus b squared, or it can be c squared, whatever that you have. But that is what you're going to have in this case, which is the hypotenuse is already there. 13 squared is equal to a squared plus b squared. These are the shorter sides, which is this side and the 5. So it is going to be a squared plus 5 squared. Okay, 13 squared, that is something like 169 is equal to a squared plus 5 squared, which is 25. So you can transpose the 25 to the left-hand side, and that will be 169 minus 25, which is equal to a squared. This is paper 2, guys. We're not supposed to stress much here. 169 minus 25 is going to give us 144. So a squared is equal to 144. So how do I remove this square on a square root? So a is equal to 12. Okay, so this is our 12 here, which is the height. So we've got 12 here. So having this height is actually an advantage because we can now calculate the area. Remember that the area of a triangle is half base times the perpendicular height. Okay, so this was item 1, item 3. Okay, so we are saying the area of a triangle is actually equivalent to half base times the perpendicular height. So in this case, this is the base from A to C. That is the base of the whole triangle, which is 10. So it's going to be half of 10 by the height, which is the perpendicular height, which is this one, which is perpendicular height, which is 12. So you multiply by 12. You've got the area of the whole triangle. So half of 10 is 5. 5 times 12, which is 60. So that is 60 square centimeters. Or you can calculate the area of this triangle plus area of this triangle. Still, you're going to get the same answer, just like what we got here of 60 square centimeters. Okay. Then we are now given that all length that we are given, all these lengths that we are talking about, they were given, okay, of this triangle ABC, they were actually given to the nearest centimeter. Calculate the least possible perimeter of the triangle. So guys, take note, we are now working with the least possible values, which means we're talking about minimum and maximum values. So we are given that all these lengths that we are given before, they are being rounded off to one decimal, which means we're talking about 13, 13, and 10. These were the lengths that we are given. So we're talking about 13, 13, and 10. So we are given that they were rounded off to the nearest centimeter. I told you guys, whenever you're given to the next a certain unit, it means to the nearest whole number. So that means before we had these whole numbers, we had a decimal before. So we're just going to find 0.5, then we subtract from that. It's a whole number, so you just have to subtract what? 0.5. So 13 minus 0.5 is going to give us 12.5. That is the least possible value. If it was maximum, you add 0.5. Okay, up you add 0.4, it will be 0.4. Okay, so we have got 13.5 again, 10, we have got, sorry guys, we have to subtract it here, so it's going to give us 12.5. So 13 minus 0.5, which is 12.5. We have got 10 minus 0.5, which is going to give us 9.5. So these are the least, because we want the least perimeter, so we have to find the least possible values. So therefore our perimeter, remember, is a triangle perimeter, you add all the sides, so it's going to add 12.5 plus 12.5 plus 9.5. Okay guys, this is paper 2. Do not waste much time adding this, just add from your calculator. You're going to get something like 34.5 centimeters as the perimeter. Okay, so that's what we actually needed to obtain 9 marks on this whole question of question number 3B. Okay, on the 3B, that is what we had from that triangle. So guys, it's best that we revise as much question papers as we can before we can write our final exams. Okay, number 4, we are given that if dx is equal to r plus qx, find the value of d if p is 3. So you're given the value of q, sorry, the value of q is 3, the value of r is -1, and the value of x is what? Is 2. So it has to find the value of d. So it's just substituting, guys, into the equation that we are given. So let us substitute and see what we are going to have here. So this is item 1. So you're just going to substitute these values. X, we've got the value of x here, which is 2. So it's going to be 2 times d, because we want to find the value of d. So the x that we are given, which is 2, is going to multiply to this d. So it's going to be 2d is equal to r here. Our r is -1. So it's -1 plus qx. Qx, that means q times x. So our q is 3. So it's going to be plus 3 times x, which is 2. So that's what you're going to have in this case. So let us find the value of d. 2d is equal to -1 plus 3 times 2, that was going to give us 6. So you can add the 2 parts here, which is going to give us 5. So you can divide by 2 both sides to remove the 2, which is affecting D. So 2 into 5, that is 2 remainder 1 over 2. So that's what you're going to have, 2,5 or 2.5. I don't know which one was best for us to write. Okay, then on the other part of the question, we are now express X in terms of D, Q, and R. That is, make X to be the subject. That is what they are trying to say here. Make X the subject. So how are we going to make X the subject of the formula in this case? Okay, so we just have to analyze from the equation, guys, that you are given. Remember, okay, let's just have it here. This is item 2. We have got dx, which is equivalent to r plus qx. So from this part, we can actually see there is x here, there is x. So in order for us to make x to be the subject, we have to collect these terms of x to one side of the equation. So I can transpose the positive qx to the left-hand side is going to be a negative. So I'm going to have dx minus qx is equal to r. So from this part, I've got x here, I've got x here. So what am I supposed to do to remain with 1x there? I'm supposed to factorize. So I have to factor out the value of x, which is common here. Our x is common, so I have to factor out x. So it's dx divided by x, which is d, minus qx divided by x, which is q, is equal to r. So from this part, I want to make x to be the subject, and I'm having a bracket. So I'm just going to divide by the bracket because it is multiplying. So if I divide by d minus q here, by d minus q, this will actually cancel. So therefore, our x is going to be r over d minus q. So that is what we could have done in this case. So there it was just issue of making sure the values of x are on the one side, and it can be either way. You can choose to take dx this side. If you were to work it that way, it means it was going to look like this. If you choose to take r to this side, it was going to be minus r is equal to qx. Then the dx to this side was going to be negative dx. Then minus r is equal to x, which is common. You're going to have q minus d. Then you can factor, divide by q minus d, which is the factor there. So q minus d cancel. So therefore your x was going to be negative r over q minus d. So these two answers are actually the same. So yeah, they're actually the same. If you substitute any value here, like you're given the values of r, you can substitute and see if you're going to obtain the same value of x in place of these values. That is to show that they are actually the same. All right, so that's what we had. Then the B part, we are given that there are 55 people attending a workshop. Okay, so these are 55 people attending a workshop. We're asked to indicate which of the food items they liked, choosing from salsa, rice, and potatoes. So this is what we have. So this is the universal set containing 55 people. So we are talking about the universal set having 55 as a total. So they have to pick from this information that you're given here, that is salsa, rice, and potatoes here. Okay, so let us save our information. We are given that S is a set of people who like salsa, and number of S is 23. So which means this S that you're talking about here, salsa here is 23. There are 23 people. And R is a set of people who like rice. So number of R is 19. So this is rice here, and there are 19 of them. Okay, then P is a set of people who like potatoes. Number of P is 12. So here in P, we have got 12 elements, which are in this case. Okay, then we have the information was displayed in the Venn diagram, and the numbers in each region represent the number of people who like at least one of those food items. So that is what we are given in this case. Find the value of X. So the value of X, guys, how can we find the value of X? So it's actually, guys, a play around type of equation where you analyze according to the diagram, because this is the only information that you are given. Okay, I can't work with this set S because there are two unknown values. There is N, there is minus X. Also, I can't work with this set P because there are two unknown values. There is X, there is M. So what can I do? I have to work with set R here, because in set R, I just have X, which is the unknown, the only unknown that I'm having. And I know that the number of elements in R here, because we are given that all those elements in R they are equal to 19. So what does it mean? If I add everything surrounded by this set R, everything surrounded by this set R, I'm supposed to obtain 19. So I'm going to add 5 plus 3 plus 4 plus x. So if I add these numbers, I must obtain 19. So I have formulated an equation from this part, so I can solve for x. Okay, if you add these numbers, what are you going to get? 5 plus 3, which is 8, 8 plus 4, that is something like 12. So it's going to be 12 plus x, which is equal to 19. So I can transpose the 12 to the other side of the equation, which is going to be a negative. So x is equivalent to negative 12 minus, 19 minus 12, which is going to give us something like 7. So this is the value of x that we are having here. So it means in place of x, we have got 7. In place of x, we have got 7. So it's going to be 9 minus 7, which is 2. That is what it simply means. Okay, so it was actually direct, but the question was to find the value of x. This is what we have on our item 1. Okay, what about item 2? Calculate the number of people who like SADSA only. Okay, so I talk about the people who like SADSA only, which means we are here instead of S. So which means they are simply saying calculate the value of n. This is your SADSA n only there, which is n. So you are simply finding the value of n. But remember that we are given the number of elements or number of those who like SADSA, all of them, they are 23. So we can work from there to say if we add just like what we did to find x, just what we did to find x. So we're going to add this n in this set of what? Of SADSA here. This is the set that contains SADSA here. So you add everything. So that's n plus 5 plus 3 plus this here, which is 2. So you add everything, equate to 23. All right, so that means we can find n. So n plus, if we add, it's going to be 8 plus 2, which is 10, is equal to 23. So n is equivalent to 23 minus 10. So our n is going to be 13, if I'm not mistaken, there. So these are the ones who like SADSA only, which is what? 13. So you can write as a conclusion, those who like SADSA only, they are 13. Okay, so that is what we are given. Then the item 3, find the number of people who did not like any of the food items on offer. So you want those who did not want any of these food items. And which one are you talking about here? We are referring to these ones outside of S, R, and P, which means we are talking about Y here. So the question is simply calculate the value of Y. But how can we have the value of Y? We must know the value of M because it's going to help us, because we know that all these sets, if we add everything, we must get 55. But if we equate to 55 now, it's going to be wrong, because we'll be having two unknown values. M will be there, Y will be there. So it means we must calculate the value of Y first. Okay, so how are you going to calculate the value of Y? Remember, we said that number of those who are in set P, they are 12. So which means I can calculate the value of Y from there. So number of elements in set P here is equal to 12. So I'm going to add everything that is surrounded by the set P here. Remember, this is your potato here. So you're going to add everything that is in this set, which means you're talking about 9 minus, which is 2 here. So you've got 2 plus 3 plus 4 plus M. Okay, then everything should be equal to the number of P, which is 12, the one that we are given. So from there, we can add 2 plus 3, that's 5. 5 plus 4, which is 9. So it's going to be 9 plus M is equal to 12. So M is equal to 12 minus 9. So M is going to be equal to 3. Okay, so the value of M here is going to be 3. So using this information, guys, like I said, it is now easier for us now to find the number who did not like any of the food items, because we are given that the number of elements in the universal set, in this case, we are referring to the universal set, all these elements that we have, they must be equal to 55. So that means I have to add everything that I'm given, all those elements. Remember, I calculated n here, n was 13. So let me just indicate here our n was 13. Okay, so it means we have to add everything. So let us add everything and see what you're going to have. So we're going to have 13 plus 5 plus 3, all these elements. Okay, so let us just put it here somewhere here. So you said we are going to have 13 here. So it's 13 plus 5 Okay, plus 3. So you don't repeat these values, plus 3, plus 2 here. Okay, plus we have got 7, plus we have got 4, plus we have got 3. Okay, so these are all the elements that we have, then y here should give us 55. So this must be equal to 55 like this. So we have formulated an equation that you can now use to solve the value of y. By solving the value of y, we are finding those who did not like any of the food items. So that was the idea there. So that is a matter of your calculator, guys. If you add everything, it's going to be something like 37, if I'm not mistaken. 37 plus y is equal to 55. So that means y is equal to 55 minus 37. If I transpose this to the right hand side, is going to be a negative. So it will be negative 37. So y is equal to 55 minus 37, which is 13. So that means, therefore, those who did not like any of the food items, they were 13. Okay, so they are giving us the same number like those who like sadza only, because it gave us 13 also. Okay, anyways, it's fine like that. That is how the question was on the sets. So guys, we got 6 marks on sets, and it was actually fine because it was direct, a little bit direct. Okay, given the matrices, we've got matrices here, P and Q. Find the value of n if PQ is equal to, okay, so this is just matrix multiplication. So you can just even do it here. Remember matrix multiplication, guys, we're given that if you multiply P to Q, P and Q, which is P, which is 3, negative 4, 5, 1 like this. If you multiply this to Q, which is our Q is 2, 8, we must get this answer, which is equal to 4n 18 like this. This is what the question is saying. So how are we going to actually solve? Remember, for you to multiply, we need row by column. So we're going to have row by column here. So let us have the first one. So it's 3 by 2, which is 6, plus negative 4 times 8, which is going to give us negative 32. So why are we adding? Because we still have numbers which are in the row and also the other number which is in the column. So that is why we have to add. Then we move on now to this row, but with the same column. So as you can see, the column is not changing. So we're going to do the multiplication 5 by 2 here, which is 10, plus 1 by 8, which is just 8. So this is what you're going to have. If we do this, we are going to obtain 4n 18. Okay, so that is what we're given there. So you can combine these two terms. 6 plus minus 32, that's 6 minus 32. This is paper 2, guys. Like I said, 6 minus 32. That's negative 26. So negative 26, if we add these two, it's going to give us 18, should be equal to 4n 18. So this is what you can do actually to cross check. As you can see here, we've got 18, we've got 18. Just the same way, these two must be equal. So you can formulate an equation to say negative 26 is equal to 4n from corresponding elements. Corresponding elements are equal. So to find n, I can just divide by 4 by 4. So that's what I'm going to have. So negative 26 over 4, what are you going to have? Divide by 4, our answer here, we're going to have negative 13 over 2. So it's negative 13 over 2, or n is equal to 2 into negative 13. That's negative 6.5. So that is the value of n, or negative 6.5. I don't know which one was best for us to write there. Okay, but as you can see, that is actually what we needed in this case. Was just multiplication. Okay, so item 2, we now need the inverse of P. So remember, for the inverse of P, what do we need? We need the determinant first. So to find the inverse of P, we are going to find the determinant first of P. So determinant of P, which can be written like this, okay, is equal to, remember, we've got A, B, C, D, which is equal to AD minus BC. So AD, that's A times D, which is 3 times 1. So it's going to be 3 times 1, major diagonal, which product of the major diagonal minus the product of the minor diagonal, that's negative 4 and 5. So it's going to be negative 4 times 5 like this. Okay, so 3 times 1, that is 3. Minus and minus, that's a plus. So if you multiply this, it's going to be 20, but there was supposed to be minus 20 and minus, so it's going to be positive, which is 23. So from the determinant, therefore, the inverse of P now is going to be 1 over the determinant, which is 1 over 23. Remember what happens in the major diagonal between A and D. These two, they will interchange. So it's going to be 1, 3. In the minor diagonal, you multiply each by negative. So you multiply this by negative, you multiply this by negative. Okay, so if you multiply by negative, it's negative times negative 4, which is positive 4. Negative times 5, which is negative 5. So that is the inverse of a matrix. Simply like that, we have got the inverse of P. All right, then let's see the other part B, which is geometry. So you've got find this, whatever that we are having there. So take note, guys, we're given that in this case, TOV is a diameter. Where is our T? TUV, TU, which means there's a T here. So our T was somewhere here. Okay. So TOV is a diameter. So, you know, guys, a diameter subtends an angle of 90 degrees at the circumference. So when you are reading this information, fill in some of these information that you know. So this is 90 degrees here or at U. Okay. And also, you know, that a tangent and a radius or a diameter, they meet at 90 degrees. So this is also 90 degrees here. 90 degrees and also 90 degrees on the other end here. This is 90 degrees, 90 degrees, okay? Then what else are we given? Then we are given that these are tangents to the circle. SWV is a parallel to TU, okay? So we're given that SWV, where is our SWV is parallel to TU. So you have to indicate that these two, they are actually parallel lines. So there is a lot that you can hear from the parallel lines. So there's a lot, guys, that you're going to have. Okay, so anyways, let us see what the questions was all about. Find one TSV. So we need TSV, angle TSV. So that's our item 1, TSV. What are you going to have? Okay, so this is T to S to V. So this is the angle that we need here. Okay, so what can we have, guys? Remember, we are told that these lines, these two lines, they're parallel lines. And we know that from parallel lines, these two angles, they are the same, corresponding angles. So this, if we have to extend this line, we can see that these two angles, they correspond to each other. This is 37, this is also 37 degrees. So this angle was going to give us 37 degrees from corresponding one, corresponding angles. So this was from corresponding angles, okay? What about the item 2, which is SVT? So this is SV to T. So we've got S here, and this is our V, and this is our T. So we need this angle here, SVT. So like I said previously, guys, this is 90 degrees, a diameter to the tangent, it meets at 90 degrees. So this is going to be 90 degrees. So that means triangle SVT, using this triangle, you know that angles in a triangle, they add up to 180 degrees. So to find this angle SVT, we are just going to simply subtract all the given angles from 180, which is 37 plus what? 37 plus 90 degrees. This is a right angle meaning to say 90 degrees. So that is what you're going to have at the end. And this can give us something like 53 degrees. Okay, so this is 53. Or you can simply say, since already we've got 90 degrees here, these two angles, they must give us 90 degrees so that we can have a total of what? 180 degrees. So you can simply subtract 90 minus 37. What do you get? 53. So if your answer, just like that. Okay, so that was our SVT, which is 53 degrees. So you're going to have 53 degrees here. Then we've got UVT. Let us cross-check UV to T. So this is the angle that we need, UVT, this angle here. Okay, so this angle that we are referring, UVT. Okay, from the tangent TX and the chord TU, we've got an angle that is in between, angle between a tangent and a chord. Remember that the angle between a tangent and a chord is equal to the angle in the alternate segment created by that chord, which is the chord TU. So if this angle is 37, it means also this angle is going to be 37 degrees. So this is one of the most theorems that is important for you to remember, guys. So that is tan chord, angle between a tangent and a chord, okay? TXU, so we've got TXU from T to X to U, that is TXU, this angle here is the one that you need to calculate. Okay, so what can we do to calculate this angle, guys? I want you to see something from this angle, TXU. Remember, two tangents, if they are drawn externally from one point to the circumference of a circle, they're actually equal in length. So these two sides are equal from u to x and from t to x. So we know that base angles are equal. So if this is 37, this is also 37 degrees at u. So this angle u is 37, this angle t is 37. So to find the angle x, we're simply going to subtract these two angles from 180 degrees. That's 37 plus 37. So if we subtract this, we're going to obtain 106. So this angle here is 160 degrees, which means we are referring to angle TXU being 106 degrees from the angles in a triangle. Okay, so that was the case. Now let us move on to the other part of the question. We are now given there. Name the triangle that is similar to triangle UVT. Remember, similar figures, they are supposed to be equiangular. So you need UVT, okay? Triangle UVT. So the first thing is to locate that triangle UVT. Where are we going to have our triangle UVT? Okay, this is our triangle here, UVT. That is U to V to T. Okay, so from this triangle, we can actually note this is 90, this is 37. So you can calculate this angle, 90 plus 37 from 180, we are going to obtain 53 degrees. So when you are referring to similar figures, guys, I told you that you take these ones according to the angles which are the same. So let me write it here so that it can be clear. Triangle UVT is supposed to be similar to the triangle that possesses the same characteristics with this triangle, where our U is 90 degrees, because this is what you have here. Our U is 90 degrees. So as you can see so far, the part that has got 90 degrees is this part here, 90 degrees, and the whole of the T this side. This is the part that have got 90 degrees. So T is equal to 90 degrees. We move on to V. Our V in this case is 37 degrees. And we've got 37 degrees in a triangle that has got 90 degrees. Yes, 37, but this triangle does not have 90, so you can't take this triangle. So we're going to move to this 37, which is on what? Which is on S. So it's going to be TS. Then you move on to T. Our T from this triangle UVT, the T that we're talking about is this 53 degrees. This 53 degrees is equal to the 53 degrees, which is at V from this triangle here. So it's at what? At V. So this triangle is going to be called TSV. That is the similar triangle to the triangle UVT, the one that we're given there. Okay, so that is how you simply work out this part. Okay, so the other part, guys, we're given that TU is 4,7 centimeters. Okay, TU it's 4,6 and calculate the radius of the circle. Okay, I want you to see something here. I want you to see something. TU, where is our TU? This is our TU here from T to U. We are given that is 4,7 centimeters. This is our TU here. All right. So if we are to cross-check here, guys, let me remove this part so that it does not affect us. Okay, this is our TU, the one that we are given as 4,7 here. So we've got 4,7 centimeters. And the diameter is V to T. The question here needs us to calculate what? What is the question saying? The radius. So by calculating the diameter, I can simply calculate the radius. Guys, this is what I actually know. Okay, so remember that radius is equal to diameter over 2. So let us just remove this part so that does not affect us. Okay, so we actually know that the radius is equivalent to the diameter over 2. So by calculating the diameter in this case, which is our diameter, it's VT. So I'm just going to take this shape here that is got V to T to this angle of 90 degrees back to like this one. We've got V, this is our O here, this is our T. Remember, this is your U, which is at 90 degrees, okay? Then we've got these angles that we are given here, which is 37 degrees, and we've got 53 degrees here, whatever, which one are you going to work with? And this side TU, the one that we are given now, which is 4,7 centimeters, okay? So it's going to be easier for us if we are to calculate VT, because we are saying VT is the diameter. So this is our diameter. And if we have the diameter, then we can find the radius. So here, this is in 90 degrees that we are having. And That means we can use our solving triangles from trigonometrical or those trigonometrical ratios that we have. Okay, so if we can use the trigonometrical ratios, that means we can choose one angle to work with here. It's either you're working with 37 or you're working with 53. So I'm just going to work with this 37 here. So working from 37, this side is actually my opposite, okay? And the one that I'm referring as the VT is the hypotenuse because it's opposite to 90 degrees. So this is our hypotenuse. So which ratio uses the opposite and the hypotenuse at the same time from your soccer tower? Remember your ratios, guys. Soccer tower. So from our soccer tower, it's opposite and hypotenuse is found on sine, where we know that sine theta is equivalent to opposite over the hypotenuse. All right, so meaning to say, since I'm working with 37 degrees, it's going to be sine of 37 degrees is equal to the opposite now, which is the one that I'm given here. And my opposite is 4,7 over the hypotenuse. The hypotenuse in this case is the one that I want to calculate, which is the VT. All right, so that means from this one, I'm going to simply solve by cross multiplying. So you can cross multiply, solve for VT. That is what we're going to have. So yes, something like VT sine 37. Okay, so this is VT sine of what? Sine of 37 degrees. So, okay, that's 37 degrees here, which is equal to 1 by 4,7. That's 4,7. So I can divide by sine 37 degrees by sine 37 degrees. Okay, cancel these two. VT is equal to, so I'm just left with this part, which you can just use your calculator here. So it's 4,7 divided by sine 37 degrees. Make sure that your calculator is in degrees. This D here has to be displayed. So that's 4,7 sine 37 divided by sine 37, sorry. It's going to be 7, something like that. Okay, so it's going to be 7, okay, 7,8097, something like that. So you write everything up to the end. So you can round off your VT depending with the degree of accuracy, or you can just leave it for now since this is not our final answer. So just leave it like that. Now let's get back to the radius, because we said the radius in this case is going to be diameter over 2, and we say our VT is the one which is representing the diameter. So now to find the radius, we are going to simply divide. So our radius is going to be VT over 2, which is 7,8097 over 2. That decimal as it is. So still on your calculator, this decimal is there. You simply divide by 2 like this. You're going to obtain 3,904, something like that. So our R is going to be 3,904, something like that. So remember, guys, your degree of accuracy to 3 significant figures, that's 1, 2, 3. So this 4 is less than 5, so it cannot change this number. So it's going to be 3,90 centimeters. Just same units that we had before. It was 4,7 centimeters here. So it means your radius also is going to be in centimeters. So that's how you simply work out these typical questions, guys. It's actually easier if you revise as much questions as possible. Okay, so let us cross-check the other part now that we have on question 6. Answer all of these questions on a sheet of plain paper provided. Use ruler and compasses only, and show clearly all construction lines and arcs. Construct on a single diagram quadrilateral A, B, C, D in which A, B is 6 centimeters. So all I said, guys, you must have a sketch. So it's going to be easier for us if we have got the sketch here. All right, so as you can see, there's an angle of 120. So remember I told you the angle has to be at the base. So 120, guys, just assume how it's supposed to be. It's supposed to look like this. Okay, so anyways, it's just a sketch, so it's not supposed to be anything smarter. Just show your sketch. So this is A, B, C, 120. So you can write A, B, C, D. It's a complete quadrilateral. So A, B, C is 120 degrees. AB 6, so AB is 6 centimeters here. BC 7, BC is 7 centimeters. CD 9 centimeters, and AD 7 centimeters. So that's what our diagram is going to look like. So from this, guys, we're supposed to construct with this information or with this sketch that we are having. Let us now construct. So we need our instruments, the ruler and the compass. This is what we are only needed to have, only ruler and compass for constructions. And if you want to measure, that's where maybe you're going to have your protractor, but for now, we just read ruler and compass. Okay. So this is what you're going to have, guys. As I told you guys, your construction always starts on a line, on a straight line. So you're just going to draw a straight line of your choice that you're going to have. In this case, I think it can actually work properly. If I do like this measurement, they'll be actually big if I use this one. Anyways, I'm going to see what is best for us. Okay, so let me just try and adjust this side. So you're just going to draw a line of your choice in this case without any hindrance. Okay, from this line, what you need actually is to have, I'm just going to keep my ruler aside like this. We need 120 from B, so we're going to mark the first point to be our B. So this one is your reference point, the one that you're going to start from. So you can just mark it anyway, depending with what you actually have. So you can just mark it here, say, okay, this is my B here. So let me just adjust. Okay, guys, sorry. Just want to adjust before I mark, okay, somewhere here. This is where I'm going to mark my point B. So from B, I'm having 120 degrees and it's inside the diagram. So it means I'm going to construct 60 degrees outside of the diagram, which is on the left side. Okay, so from the left-hand side, that is where I'm going to construct my 60 degrees. By constructing 60, remember, we are constructing 120. So remember, how you construct 60, just mark an arc, then from that point of intersection of the arc and the line, you mark again back to the line. They must meet at a certain point. All right, so they must meet at a certain point. I'm just going to start somewhere here. Okay, so this way they are meeting at this point. So that means that angle that you see there is now 120. 120 degrees, the one that is going to remain. So that's what you simply need in this case. Okay, so let's see if we are going to be able to join. Yes, we are able to join this part. I don't know, it's going to disturb our sketch there, guys. I think our sketch is going to disturb us because it's now entering part of the sketch there. Okay, so anyways, let me just adjust this side, but it's going to enter into that sketch. Okay, anyways, let's see what it's going to look like. If there is a need for us to adjust, then we'll adjust later on. So this is our 60 degrees, the one that we are having here. So we are having 60. That means this remaining angle is the one that we need, which is 120 degrees, which is at B. Then from B to C, it's actually 7 centimeters. So here we can just measure our 7 centimeters from our ruler, but giving this information, using these values, guys, is going to be big. As you can see on my part, 7 centimeters is going to be somewhere here. And this is going to be too much big. I don't know if it is going to be clear, but let me just try. Okay, so what you do is that you actually measure from this part. So if I'm to measure using this, guys, it's not going to allow me. As you can see, it's shortened. Okay, so I'm not going to use this side. I'm going to use just 7 centimeters of a choice from this part of this my canvas here. So this is where I'm having my 7 centimeters somewhere like this, 7 here. Okay, so this is my 7 centimeters, very, very small. Okay, so it's gonna be very, very small because of this part here, so that it can be clear. Okay, so this is where we are having our C at this point. Okay, so this is your 7 centimeters. We are having C here. Then from the same B that we are talking about, from the same B to A, it's 6 centimeters, and it's along the 120 centimeters that we've constructed. So it means if I am to measure 6 centimeters, which is this one, is 6 centimeters somewhere here. Okay, if I'm to have this as my 6 centimeters, I'm just going to mark with the 6 centimeters that I'm having. So this is what I need here. I'm going to mark 6 centimeters from this point along this line. Okay, so this is your 6 centimeters. You just mark somewhere here. So at the point where you have marked, this is where you're going to have your point A. So this is your point A, and this will be 6 centimeters here. Okay, so you've got 6 centimeters. Then how are we going to find the other point now, which is the point D? Because this one, we do not have a reference of anything. These two, they have a reference of 120 degrees. So this is what you're going to do. You're going to measure 9 centimeters from C. You just measure that one and mark a certain distance from C. So this is our 9 centimeters, something like this. Okay, that's 9 centimeters like this. Okay, so you just measure 9 centimeters from this point that you have at this point here. Just your 9 centimeters, you just mark anywhere along the line. Okay, so I'm just going to mark somewhere here. I don't know exactly where it is going to be, so I just have to mark anywhere along this line. That's our 9 centimeters. Okay, you do the same from A, but from A, this time you measure 7 centimeters, okay? So I have to measure 7 centimeters. So this is now 7 centimeters here. Okay, so with these 7 centimeters, I'm placing it at A. So I must be at point A. I have to mark an arc from point A back to this point, okay? So as you can see, these two, they meet at this point here. This is where these two meet here. Where these 2 points meet, that is where we are having our point D now. So it means we can join from C to D, from A to D. We are now having that flexibility because we now know where our point D is located. So that was the idea on this one. So just like this, guys, we can mark, we can just join. So remember, it's construction, just join, just pass this point a little bit like that. Okay, do not be like you're drawing, guys. This is constructing. So just make sure that you just make sure your points, they are not that much like to exact to the point. Okay, I think you understand what I'm trying to say. So this is what we're going to have at the end. So that's our diagram, guys. It was going to look like this, and that means this is CD, which is 9 centimeters. This is AD, which is 7 centimeters, like that. Okay, so that's what our shape was going to look like. And you can just, okay, for this case, I'm just going to remove this part. So, but you're not supposed to erase anything, guys. You're not supposed to erase anything. You leave your diagram the way that it is, okay? No erasing of anything. Okay, anyways, that is what we're supposed to have, a simple diagram like that. Okay, so the other question, let us get back now to our question. I'm just going to shift. I'm not zooming anything, shifting. Now construct the locus of points equidistant from, take note, guys, A, B, and AD. So remember, AB is a line, AD is a line. So we are going to bisect the angle, which is angle A, which is repeating here, A here. So we're going to bisect angle A from AB, AD. Okay, so this is AB, AD. So we're going to bisect angle A. So how do you bisect angle A? Remember, guys, the lines that are creating angle A, it's AD and AB. So we're going to step at point A, the needle point at point A, just open a distance where you're going to mark from the line AD. You just mark a point on line AD. You do the same on the line AB. You just mark a point. From the 2 points that you have marked, you are supposed to construct an arc now back inside the diagram here, because we want to bisect this inside this region, mark an arc like this. All right, back to this point again, which is on line AB. You're supposed to do the same, mark an arc like this one. Okay, so this is what you're going to have. So from these 2 points that we have, we can actually join from A to that point that we are having. That means we have bisected this angle, or we have divided this angle into 2 equal parts like this. Okay, I'm just going to shift this side. Okay, let me shift this one. Yeah, something like this. So it's, guys, yours is a direct, but as for me, it's going to take some time. So, but it was just going to be like that. So that is the bisector of the angle. Okay, so by doing this, guys, we have bisected this angle that we are given. Okay, so let us cross-check the other question. The locus of points inside, take note, guys, inside the quadrilateral ABCD, that are 3 centimeters from BC. Okay, but they are inside the quadrilateral. Take note, the locus of points inside the quadrilateral ABCD that are 3 centimeters from BC. So 3 centimeters from BC, we're supposed to have something like this. If this is BC, we're supposed to have a pair of parallel lines where we've got parallel lines like this. But now they are saying inside the quadrilateral. So which means we are going to construct 3 centimeters from BC. This is our BC here. We are going to mark 3 centimeters. So remember us, we are using this, but you're supposed to measure 3 centimeters exactly. So here, I'm just going to measure mine here. Okay, this is what I'm going to do. Let me just shift this side. So 3 centimeters, actually something like this on my thing here, 3 centimeters. Okay. So remember what you're supposed to do. You're supposed to have a pair of parallel lines whereby you mark an arc on top here. Let us change to like here. We're supposed to mark an arc from point B. You mark an arc like this. You do the same from point C because that is where our line is taken from. Okay, from BC, you mark an arc also on top like that. So that is what we're supposed to have. We're supposed to have even the other arcs down here, but now we are not going to have such a condition. Why? Because we're told inside the quadrilateral. So we're just going to use the side that is what to the quadrilateral, this side. Okay, so from this side, we are going to join these, the top of these what of these arcs, but your line is not supposed to exceed from the quadrilateral. It's supposed to be in. We are supposed to join, guys. This is what was supposed to happen. You're supposed to join from this point to this point, even outside, but because they told us that it's supposed to be inside the quadrilateral, therefore it's supposed to be like this. Okay, so you just join in within, as you can see how your line was supposed to be, but you just join inside to this point that is inside the quadrilateral. Okay, so this line that we have drawn here is 3 centimeters from BC and it's inside the quadrilateral. That is what the question is actually referring to. All right, let's get back to the other part of the question. Let's see what we are given. Now we are given to construct the shortest line from C to AB. Take note, to AB produced. What does it mean when they say AB produced? AB extended. You can extend that line AB. Remember, how do you construct shortest distance? They are simply saying construct the perpendicular from a point, because a line drawn from a point to a line, the shortest distance is at 90 degrees. So we're simply constructing the perpendicular from point C to line AB. Remember, guys, what I told you about constructing perpendicular from a point. So it's from point C here to AB produced. That means you can extend this line AB. So we're now back, guys, to that line that we erased before. We have to extend it again. So you see what I was saying, that you're not supposed to rub anything. So this one has to be a little bit extended. Okay, so something like this. So remember the bisector, the one that is going to give us 90 degrees from a point C. So it's from point C here. Okay, I was supposed to even extend this side a little bit. It's not like 2C, but it's also supposed to be simultaneously extended. I'm just going to extend a little bit here. Okay, so the bisector, I mean the 90 degrees that you're going to construct is from this point C, from C here. So this is what you're going to do. From point C, you're going to open a distance that you're going to use to mark an arc. And take note about this arc that you're going to mark. This arc is supposed to cross the line into 2 equal parts, the line AB. Okay, so it means for us to have this arc, guys, it has to be wide enough, okay, to cut AB at 2 positions, not equal, but at 2 positions like this. Let's see, this one can actually cut. No, it's too big. Let's decrease like this. Let's see. Yeah, this one can cut into 2 parts. Let's decrease again a little bit. Okay, let's see. This one can actually cut. Okay, so that is what it actually means. Okay, so this is what you're going to do. You construct that arc like this. Okay, so this is the arc that you have constructed, which cuts or which crosses the line AB that you have produced or that you have extended into 2 parts. It's not that it's supposed to extend AB like this, guys. Okay, no. It's not supposed to be like that. Okay, this marker now. Okay, let me choose this one. This is your AB extend. It's not supposed to be in within AB, no. As long it is on the line AB, whether inside the line or even outside of the line AB. This is A to B. So it can be even like this. as long it is within the line AB that you are given, it does not affect this part. Okay, so this one was the best one that you're going to have. Then from that part that we have, what are you going to do? We are going to step now back to that point that we are given, which is the point what? Point C. So we step at these 2 points that where the arc and the line meet at this point. We are supposed to mark an arc without changing this length that you have used to mark the arc. Don't change the length. You mark an arc on the other side, and you also mark an arc, and this arc is going to pass at C. As you can see, it is passing through C. Okay, you do the same where this yellow line, the yellow arc here, and the line meets here. You mark an arc, is going to pass through C on this side, and on the other side, it is going to pass, it is going to meet the other line, like the other arc, like this one. So these 2 arcs, they meet at a certain point. So what do? I have to join these points that I have in this case from C to the point of intersection. If I do this, it means I have actually constructed an angle of 90 degrees from C to line AB. Okay, just extend a little bit here. All right, so that is what we're going to have. So if I'm to draw a line from this point C, from our point C here, to this line that is AB, passing through this arc, the line that I've drawn here is at 90 degrees. So that is what it means. So this angle here is at 90 degrees. So that is the shortest distance from C to AB, or the perpendicular from C to AB. That is how you construct that one. So I think it's pretty clear. Let us see the other part that we are given. Now you are given on B. So this, I think we no longer need this one. Mark and label clearly the point P inside the quadrilateral. Take note, where is it this? It is inside the quadrilateral. This is where our point P, it's inside the quadrilateral, which is equidistant from AB and AD. Remember the equidistant of AB and AD on item 2, we bisected the angle. And 3 centimeters from BC, 3 centimeters from BC is the one that gave us a parallel line. So this is where we are talking about. This was the equidistant from our item B, this one, which bisected angle A. And this was 3 centimeters from BC, which means we need the point of intersection here. Where these 2 meet, that is where we are going to mark our point. And that point, after naming, we are going to name it P. So they are saying this point is to be referred to as P. So that is where our P is going to be located. Okay, so that was this part, guys, on construction. As you can see, it was pretty clear, and all you need is to work on more questions in order for you to actually understand the construction part. But as you can see, it's actually nothing. It's actually nothing, guys. We just have to work more questions, more revisions. It can actually help as we are moving. Okay, so that was question 6. Let us cross-check the other question, which is question 7. Express the logarithm of 2 minus 2 log 50 as a logarithm of a single number. Okay, so this is what you're asked to do. Express this as a single logarithm. Okay, so that is 7a. So it's 2 minus 2 log 50. Okay, so guys, take note, we are in base of 10 because the base is not given. Whenever the base is not given, it means you're in base of 10. So for you to write this as a single logarithm, you are supposed to ask yourself, what does this 2 actually represent in terms of logarithm? What does this 2 represent? So remember, in base of 10, 2 is from logarithm of 100. So this is the logarithm of 100 in base of 10 minus 2 log of 50. Okay, now at this stage, I can use the laws of logarithm because I have now have logarithm. So I can raise the 2 to be an exponent. Remember, from our P log M is equivalent to log M to the power of P. So that means I can raise this to be the exponent. So it's going to be logarithm of 100 minus logarithm of 50 to the power of 2. So I'm going to have logarithm of 100 minus 50 to the power 2. That's 50 times 50, which is 2,500. Okay. So from this part, what am I going to do? I'm subtracting logarithm, and now we have a single logarithm, and they're subtracting. So I divide the numbers from our logarithm of A minus logarithm of B is going to give us logarithm of A over B, sorry. So it means you're going to divide the numbers, not the logarithms. You divide the numbers, which is 100 and 2,500. So these are the numbers that you're dividing. So it is going to give us log of a single number, which is 100 over 2,500. You can use your calculator, 100 over 2,500, like this. Okay, so this is 25,000, not okay, 2,500 is going to be 1 over 25. Okay, so this is what you're going to get, which is 1 over 25. So that's a single logarithm. That's what they're trying to say in this case. Okay, then let's see the other part on B. We have got a diagram that we have here. So I'm just going to remove this part, okay, on this page only. All right. We are now given on the B part here, that's part of, yes, these are actually the same. Let us read the information so that we can understand what is happening there. In the diagram AB, this AB, that's A, B, and C, they intersected E, and they are given the other lines, and they are given this, they are parallel. If we can check, we are not given from the information, but we can see that, okay, we are given that they are parallel. Okay, the lines A, D, GF, and CD are parallel to each other. Yes, okay, so these are parallel to each other. And being parallel to each other, we are also given that these two sides are equal. F to G and B to C, these two, they are equal, and it's equal to 4,2. So it means also this one is 4,2. Okay, now the question is describe, take note guys, when you're answering these questions, describe fully the single transformation that maps triangle BCE onto triangle GFE. Okay, this is what you're going to have. I want you to see what is happening here. We are talking about two triangles here, which is a BCE and what it's what a BCE, this one BCE and GFE. These two triangles that you see, by merely looking at this, we can see that these two triangles, they are the same. They are actually the same. So which means we are referring to congruent figures here. These two triangles, they are congruent to each other. So if they are congruent to each other, which means the transformation that we can expect to have here is translation, reflection, or rotation. But we can't be talking of translation because we know that under translation, we must be talking of parallel lines of equal length. Reflection, we must be talking of parallel lines of unequal length. It is only rotation where we see the object and the image now crossing each other when you join the points, like what is happening, they are crossing each other at E. So definitely this is a rotation. So that's what you're going to have in this case. So it is a rotation. Remember how you describe a rotation. It is a rotation. Then you need the center of rotation. And I told you the special type of rotation, when you join the points like this, they cross each other at one point. That is an angle of 180. So we know that the angle is going to be 180 degrees. What about the center? Where these crosses each other, they are crossing each other at point E. So that is going to be your center. So center E. Or you can, I don't know what you can write. You can write center about the point E, or center E, it's fine like that. Okay, so that is what we're given, just like that, guys. Okay, anyways, let's us see the other part. ADE is the image of a BCE, okay? They are saying ADE, which is this bigger triangle from A to D to E, is the image of the smaller triangle. If truly these are parallel lines, because we're going to formulate similar figures, it means this is an enlargement. The bigger triangle is an enlargement of this. But if these two are equal like that, it's a rotation. But this one becomes an enlargement now. So that one is enlarged. That's why we are given that it's an image under an enlargement. That one you're supposed to know it, because they can ask you to describe. If they were, if it was you describing, you're supposed to say it's an enlargement. But now already they told you. What they just need is for you to state the center and the scale factor of the enlargement. Okay, so the center is not going to change. The center is still E, because you are mapping this triangle onto this other triangle. Oh, guys, let us cross check which triangle are we mapping. Let us cross check our triangle. It's BCE, exactly, BCE. So we are mapping this triangle onto the bigger triangle. So the center still remains as E. Okay, so the question was for us to state the center and the scale factor. So our center is going to be E. All right, so sorry. So we said our center. Okay, let's just wait for this to save a little bit. So that is the idea there. So our center is going to be E, and the scale factor, remember guys, I told you about the scale factor, that the scale factor is actually the image line over the object line. Okay, the image line over the object line, which is the image line we are referring to the image. Remember, this is the image, so these two sides correspond. So you're going to take the corresponding side on the image, which is 10,5. That is the corresponding side, 10,5 over the corresponding side on the object, of which the object is 4,2. All right, but you are supposed to take note there. Okay, let's divide. I'll explain later on. 10,5 divide by 4,2. This one gives us 5/2, or is 2,5. Okay, so you're going to have 2,5. But take note of what is happening, guys. I told you when the object is on the other side of the center and the image is on the other side of the center, like what is happening, the scale factor is a negative. But if both are found on one side, the object and the image, they are on one side of the center like that, they are going to carry a positive scale factor. So this one is going to be negative 2,5. That is our scale factor there. Okay. So I hope everything was pretty clear. All you needed there was the information, which is direct information actually. Okay. So let us cross check the other part of the question. Now you're given these diagrams. I don't know, these triangles, I don't know if they are clear, but guys, let us just hope. But this is 0 here. This is 1, 2, 3, 4. This is -1. This is -2. This is 1 here, -1, -2. Okay, so this is what you're given. And this is U. So this was U. This is V. This is W here. And this is U1, this is V1, and this is W1. Okay, so that is what you're given, guys, the x-axis and so forth. Okay, so the question now is from this diagram that you are given, describe completely the single transformation which maps triangle UVW onto triangle U1, V1, W1. Okay, so what is the transformation that is mapping this triangle onto this? Okay, so cross-checking, guys, on the diagram, we can see that we are supposed to expect to be talking of shear and one-way stretch. The way that, because the UV is still the same, U1, V1, it didn't change. So which means enlargement is totally out. If enlargement is totally out, two-way stretch is also totally out, of which we can't be talking of isometry. We can't be talking of reflection and translation on this one. We can't be talking of these ones. Okay, so we have to test, is it truly a shear or a one-way stretch? Remember what I told you for shear, that you have to extend your lines. If you extend your lines, they are going to meet in the on one line. So already here, guys, there's no need for us to extend these lines. They already meet in the y-axis. I want you to see what is happening from U to W here, U1 to W1. They meet in the x-axis at this point. Okay, which is the same thing from V to W here, from V1 to W1. They also meet in the x-axis. So that makes us to say our x-axis is the invariant line. But having the invariant line is not the answer. That is where we are starting now, because we now know that we have got our x-axis as the invariant line. Remember, I told you, for you to know that it's a shear or a one-way stretch, it is the invariant line which helps you, because for shear, points move parallel to the invariant line, while for one-way stretch, they move perpendicular to the invariant line. So parallel, which means they will be like this, perpendicular, they will be forming 90 degrees, the way points move. Okay, so let's cross-check which one is it. According to the invariant line, which is, because we are saying this is your x-axis, this is your invariant line, this one, your x-axis, this line, where these lines meet. So how does these points move? Are they parallel or they are perpendicular? When I'm saying how do points move, I'm saying from this U that we have here, going to this U1 that we have, this or U on this side, from this W here, going to W1 here, how are these lines treated with respect to the x-axis? As you can see, we have got same distance. We are maintaining same distance throughout. They are parallel to the x. Also, this one is parallel to the x-axis. So that makes it to be a shear, because a shear is the one that moves parallel to the x-axis. Okay, so that means our transformation here is a shear. So now we can describe it is a shear. All right, so already the invariant line is there. Remember, on shear, you need the the invariant line, which is x-axis invariant. So x-axis invariant, what are we left with? We need the shear factor. Okay, so that is what we need now, the shear factor. And I told you guys that the shear factor is distance moved by a point over distance of that point from the invariant line. So it's actually the distance moved by a point. A point has to move, okay, from where it was, distance moved by a point. So it's by a point over distance of that point from the invariant line. So it will be from the invariant line, which is the x-axis invariant. So let us cross-check what is happening on these points. Distance moved by a point. W here moved from where it was, V, all these points moved. Okay, W here, it moved from where it was to W1 here. So how many units according to this is 1, 2, 3. So it's going to be 1, 2. So W going to W1, it's a positive. Look at the direction where it is going. It's going to the positive. So it's positive 2. Okay, so we're going to have distance moved by a point. We got positive 2 over distance of that same point, but from the invariant line. So we are talking about the point W because it's the one that we are talking about. So this W here from the invariant line, which means from the x-axis going to W, we are going down. We are saying W, we are going down, and it's a negative. So from this point to W, it's going down. We are going downwards, which is -1. It's just one box, which is 1 unit. So it's -1. So it's going to be 2 over -1. So direction is also very, very important. So our stretch factor is -2. We can prove with another point. Let us see what is happening to U. From U here to U1, remember, this is your U1 here. It's the same. We're going to move 1, 2, but we are going to the negative side. So it's going to be -2 over distance of the same U that we are talking about from the invariant line. Talking of the x-axis going to U, now we are going up, which is a positive. So it's just 1 unit going up. So as you can see, -2 over 1, that's -2. So it corresponds throughout. Try to use V and V1, you're going to get the same answer, just like what we did. Okay, anyways, that is what we're going to have in this case. Okay, so the other question now is point U, which is this part on item 2. We are given point U2 is the image of U under a two-way stretch. Okay, find the stretch factor with y-axis. Okay, so we need to find the stretch factor with the y-axis invariant. Okay, so actually this is what was the easiest way for us to have this part here. If we are to given, remember, how do you find the stretch factor? Okay, with the y-axis invariant, we are saying the stretch factor is distance moved by a point over distance from the invariant line. Okay, so we are talking about the point U, which moved to U2 over the distance of that same point U, but now from the invariant line. Your invariant line is the y-axis now. So it's going to be from U to U2. What is the distance from U to U2? This is our U2 here. Okay, this is your U2, which is written here. This is our U2 here. So from U to U2, that is the question. What was the distance that you moved from this U to U2? Okay, so according to this way that we can see, it's actually a +2 that you're going to have, and versus 1. Okay, so it was supposed to be 2 over 1, because according to this, I can see that there are 2 boxes that I can have over from this U, from the y-axis is going to be 1. Here I just have 1 box, so it was going to be 2. So it was going to be 2 over 1 as the stretch factor, like this, 2 over 1. Okay, I hope it's clear. Okay, anyways, this one is, it actually needs someone who actually understands transformation. If you now understand transformation that way, you can take it that way. But let's say you do not understand this transformation to that level. What can you do? Remember, this is a two-way stretch. So you're going to use this concept here. Okay, this is a two-way stretch. We actually know that Under any transformation, a matrix, when it is multiplied to the object, it must give us the image. All right. We are talking about a two-way stretch where I told you the matrix for two-way stretch is H00K like this. So what I'm going to do, I'm going to find the matrix, because if I have the matrix, I know that this H here that I'm having here, this H that I'm having here is our stretch factor. Okay, this H that we are having is our stretch factor for the y-axis invariant when we are having y-axis invariant. This K that we see here is our stretch factor when that moment the x-axis is invariant. X-axis invariant. That is what it means. So by having the value of H, I am actually having the value that corresponds with this way in this case. Okay, so that can actually having, okay, here we are saying parallel. Okay, let us get back here, our stretch factor. Okay, with the y-axis invariant. Okay, remember y-axis invariant is supposed to be like this, H0, 0, 1, like this. Okay, you can just use the loop concept like this. This will be y-axis invariant. So we need this value here. So this was not going to give us 2 here. So this one was the opposite one. So this was not going to give us 2. It was going to give us another one. So let us prove with this one. The 2 is for the x-axis. Sorry for this one. This one is for the x-axis. Okay. So anyways, let us have it here. This is what you're going to do. Matrix, since we said our matrix is H0, so I'm going to use H0, 0K like this, times the object. The object is the point that I am mapping here. I am mapping the point what? The point U onto U2, which is the image. So I'm supposed to multiply to the point U. Okay, this is our point U. What are the coordinates of point U? We need the diagram now. Point U is 1, 1. This is our U here, which is 1, 1. So if we multiply this matrix to point U, which is our object, which is 1, 1, we must get the image, which is in this case, sorry, let us just do this. All right, we have got 1, 1 here. We must get the image. We say this is your object and our image is U2. So we must get the coordinates of the image, which is U2. That's what you can do as an equation. And your U2 is 3, 2. That is 3, 2. Okay, that one is 3, 2. So that means we can simply multiply 3, 2 like this. Okay, so let us multiply row by column. So it's row by column H times 1, that is H plus 0 times 1, which is 0. 0 times 1, that's 0 plus K times 1, which is K. So this is going to give us 3, 2. So just like what we did on that question on multiplication, where we multiplied and got a single, like a single matrix, we've got H and K here, which is equal to 3, 2. If we have a single matrix, means H is 3 and K is 2. And we said H here, remember our matrix is supposed to be H0, 0, K like this. So our H is 3. So in place of H, we can substitute 3, 0. In place of K, we can substitute 2. So we said the one that affects for the y-axis invariant is the what? For the y-axis invariant is going to be the H. So our H here is 3. So our still was 3, not 2. So 2 was for x-axis. Okay, so that one, like I said, our answer is going to be 3. So the stretch factor with the y-axis invariant was going to be 3. That is our stretch factor there. All right. So this is the matrix actually for our two-way stretch that we are having. As you can see, this is a matrix for two-way stretch, guys. And now the question, calculate the coordinates. So actually we needed this matrix because that is the only way that we can now calculate the coordinates of what? Of V2, the image of V under these two-way stretch, which means under this matrix that we have here. This is what we are going to have. So this is 2. The second part, so we're going to have it, our item 2 here. So what we know, we simply know, guys, this part does not change. Matrix times object should give us the image. So this is our matrix 3, 0, 0, 2 times the object. Now, which point are we transforming? We are transforming V to give us V2. So we need the coordinate of point V. What is the coordinate of point V? We get back to our diagram here. This was our V originally. Here our V was 2, 1. So we're going to multiply that by the matrix, which is 2, 1. Okay, so our matrix times 2, 1 should give us the image. Okay, so let us multiply row by column. What are we going to have at the end? So we've got this row to this column here. That's going to be 3 times 2, which is 6, plus 0 times 1, which is 0. We move on to this row and this column again. So it's going to be 0 times 2, that's 0, plus 2 times 1, which is 2. So if we add here, we're going to get 6, 2. All right, so this is the image, which means these are the coordinates of the point V2, which is 6, 2. So that is where our V2 was going to be actually located from this information that we can see here. Okay, guys, so that's how they can actually ask some of these questions from this question paper. So all we need is to revise as much questions as we can, That's actually the only way out that we have. Okay, anyways, on number 8, we are now given, in this case, if G is equivalent to -5, 2H is equivalent to 3, 4, express G plus 2H in that format. Okay, so what does this part mean? Actually, this is just okay, G plus 2H, just substitution. Your G here, that's -5, 2, so it's -5, 2 plus 2H. So your H in this case, that's 3, 4. So it's just 3, 4 here. So you're gonna have -5, 2. Then we can multiply. Okay, this is a plus here. So it's 2 times 3, which is 6. 2 times 4, which is equivalent to 8. So remember your vectors, you have to add corresponding elements. So it's -5 plus 6, which is 1. 2 plus 8, which is 10. So it's going to be 110 like this. Okay, so that was actually a direct question. So we're going to see the B part now, where we are given a diagram that we're supposed to work from. So let's see how actually we're supposed to work from this diagram. All right, so looking at the diagram, guys, you must understand your diagram. Your diagram, you must understand it very, very much. Okay, so anyways, in this diagram that we have, it's a parallelogram. So by the way that you are given, it's a parallelogram, which means you are supposed to know the properties of a parallelogram. Remember, a parallelogram, we know that opposite sides, they are parallel and equal. So these two sides, they'll be parallel and also they'll be equal. So that is the concept that you're going to use. Sorry, also on the direction, you are supposed to show that they are parallel. The direction is to, these parallel, they must face the same direction. So it means if we are given O to A, we are given C to B. So from C to B, our vector is going to be vector 4P, just like what we're given O to A, using the same direction. From O to C, if it is 5Q, then it means from A to B, it is going to be 5Q, using the same direction, because these two, they are opposite. These two sides which are opposite, they are parallel, and at the same time, they are equal. So they are going to be also equal in terms of the vectors. Okay. Now we are given that from A to X that we see, we are given is S to XC is 2S to 3. So AX, S to XC, that is 2S to 3. So here we've got 2 parts, here we've got 3 parts. Okay, so the first equation expressed in terms of P and or Q vector AC. So vector AC, guys, is direct. You can take away, it is complete. From A to O, it's complete. Then O to C, or we can use A to B, then B to C. Whatever that you're going to take, you're going to have the same answer there. Okay, so this is our first item of number 1, which is AC. So we said you're going to take A to O plus OC. Okay, so from A to O, we are opposing the arrow. We are going this direction, the arrow is going this direction, so it's going to be a negative. So it's negative 4P. From O to C, we are maintaining the direction, so it's going to be a plus. So it's going to be plus 5Q. Okay, so that's our answer, guys. Let me just write it clearly. So it's minus 4P plus vector 5Q. So that's what you're going to have in this case. Okay, then OX. This is what you're going to do from O to X. If we are to cross-check, we are supposed to take a root that is complete. And since we have AC, and we are given the ratio here of AX to XC, which is 2s to 3, which means the whole of AC is going to be 2 plus 3, which is 5 parts. So this whole AC is going to be 5 parts. And according to the vector, we have got our vector AC here. Okay, so in order for you to have the vector OX, this is the route that you're supposed to take actually from O to X. We're supposed to take the route from O to A, then A to X. O to A plus A to X. But we do not have the vector AX. This one, we can use the ratio now because we are given that from this part A to X is 2 parts. So it's going to be 2 parts out of the whole of AC. And AC, the one that you're given, it carries 5 parts. So it's going to be 2 over 5 of AC. All right, so that is your vector AX. So it means here to find OX, we are going to substitute from O to A. We have it. This time we are maintaining the R. We are going this direction. So it's going to be 4P. So that is O to A, which is 4P, plus AX, which we said is 2 over 5 of AC. So it's going to be 2 over 5 times vector AC, so times vector AC, which is this one that we obtained here, minus 4P plus 5Q. So we're going to multiply by minus 4P plus 5Q, like that. Okay, so all you need is to expand your brackets to find vector OX, which is going to give us 4P, expand by 2 over 5. So you're simply multiplying like this, 2 over 5 on your calculator, 2 over 5, multiply by, this is negative 4. So you multiply to negative 4, which is going to give you negative 8 over 5. So this is negative 8 over 5 vector P. You do the same, you're going to obtain 2P or 2Q. That one, if you do that, you're going to obtain 2Q because the 5 and 5 will cancel. Okay, so collect like terms from the vectors. So you're going to have vector 4P and minus 8 over 5P. These are like terms. So you're going to subtract 4 minus 8 over 5. So simply on your calculator, guys, 4 minus 8 over 5, like that. You can obtain your answer, which is 12 over 5. So you're going to obtain 12 over 5 vector P plus 2 vector Q. Okay, so this is going to be our vector OX in terms of P and Q. All right, so let's move on and see the other part of the question. We are now given that Y is a point on AB. So there's another point which is referred to as Y here, which is a point on AB such that AB AY over AB is equal to K. So what does this part? It's the way that you're given sometimes a scalar. They can give you a scalar in this way to say AB is equal to AY over AB is equal to K. So what it simply means, you can remove the scalar here. You can remove this fraction by cross multiplying. So it means AY, vector AY is equal to K vector AB. That is what it means. So remember, you are used to this format. Now they want to confuse you. They are giving you as a fraction. So you see how they can ask these questions, guys. Okay, anyways, that is what it can be written like. So the question now is from this AY that we are given, we are supposed to express vector OY in terms of P, Q, and K. And the only part now that carries K is this AY that we have here, is the one that has got K, which is a constant. So which means we are supposed to first find the vector AY in terms of K. We are given that this vector AY that we're talking about, it is equal to K times vector AB. Do we have vector AB? We have to cross-check now from what we calculated or from the diagram. From the diagram, AB is there. Our AB is 5Q. As you can see, our AB is 5Q. So we're going to multiply by 5Q like this. So multiply by 5Q. That means we are going to have K times 5Q, which is 5KQ. This is our vector AY. Okay, so it means from A to Y here, from A to point Y that we see is going to be K 5Y like that, 5KY like that. Okay, 5KQ. So the question now is for us to express this vector, which is OY. So in order for you to have the vector OY, which means AY has to be part of that root because it is the only root so far that carries K. So it means we must have AY in this root that we need to find the vector OY. We must include AY in that root. Okay, so which root are we going to take? from O to Y here, this is what we are simply saying from this point O to point Y. I don't know it is going to pass through A, but this is what is going to be. So we are going to take this from O to A, then A to Y. As you can see, we have involved vector AY is now included. Okay, so it's a OA plus AY. Okay, so this is what you're going to have, O to A plus A to Y. Okay, let me just use the normal one. So it's going to be, we said from O to A plus A to point Y. All right. Given the vector Y, because already the vector Y is there, all right? So which means we can take advantage of that. We can actually take advantage of the vector Y that we are. All right, sorry for that, guys. It's just stopped unexpectedly. So anyways, we said we needed the OY, so I'm just going to write that expression. Actually, I have it somewhere. We said we are going to have our OY. Sorry for that, guys. This thing, it just stopped unexpected. I don't know what actually happened. So we said our OY was going to be OA plus AY like that, and our AY we determined it. Remember, our AY was it was 5KQ. All right, it was something like this. Okay, so we are just going to substitute here, which is O to Y, which is OA, which is 4P, so it's going to be 4P plus AY, which is this AY that we have, which is plus 5KQ, like that. Okay, so this is going to be your vector or Y, like just like that. It's just a matter of what? Substitution, guys. As you can see, it was just a matter of substitution there. So I think it was pretty clear. We're going to move on to the other part of the question. Now you're given on item 3, if given that OY, this is what we are used to now, the way that they are giving us on item 3. So it's just the same way, guys, but here they just wanted to confuse you here. Okay, now you're given that OY is equal to H or X. So this is what you're given, where H is a scalar, is a constant, which is the same as a scalar. Write down OY in terms of what? In terms of this. Okay, so what we need is just like what we did previously, we have to substitute H times OX. Do we have OX or did we calculate OX before? Yes, we calculated. If you still remember that OX, still have it. We got something. Remember, we got something like a 12 over 5. It was 12 over 5P plus 2Q. That was our OX. Okay, so that means our that was our OX, and we need OY here. Sorry, guys, the way that I'm writing here. So actually, I'm okay, it's fine. Let me just correct. This is OY here. I hope someone was saying this to say, okay, what is happening now here? Okay, this is H. So multiply by H, that's going to be H times 12 over 5, which is going to be 12 over 5 HP. Okay, H times 2 here, which is going to be 2HQ. So that's our vector Y in terms of H. Like this, we are done. Okay, then what are we having now? On the item 4 part, we are now given on item 4 using the results in item 2 and item 3, which is these ones that we got here. Item 2, this or item 2, and this or item 3. So they are saying from these results, find the value of H and the value of K. Okay, so remember, guys, I told you that in order for you to solve this type of equation, these two vectors, they are actually the same. OI here and OI, they are equal. So what are you simply doing? You are simply taking these two vectors that we are given, OI and OI. The first OI that you're given is 4P plus 5KQ. So they are actually the same. So we are going to simply equate the part that has got vector P together. So the constant here for vector P is 4. So 4 is equal to the constant on vector P here, which is 12 over 5H, which is the same if you move to Q. The constant of Q here is plus 5K, so it's a positive. 5K is equal to the constant of vector Q here, which is positive 2H. So this is actually 2H. So you formulated equations from equal vectors, therefore you can solve. So how you solve, guys, is I don't know how you're going to do it, but as you can see, it's actually clear that we can take advantage of the first equation here because we just have one unknown. It just happened. So there's one unknown, so you can just cross multiply on these two. 5 times 4 is 20 is equal to 1 times 12h. That's 12h. So you can divide by 12 here, you can divide by 12 here. That means this can cancel. So h is equivalent to 20 over 12, of which you can use your calculator here. 20 divide by 12, which is going to give us 5 over 3. So our h is going to be 5 over 3. So we have the value of h here. So we're going to simply substitute this h in place of h on the other equation. So 5k is equal to 2 times 2h means 2 times h of which your h is 5 over 3. So if you multiply, 5k is going to be 2 times 5 over 3. You can use your calculator, or 2 over 1. 2 times 5 is 10 over 1 times 3, which is 3. So to find k, I don't know what you're going to do. You're going to cross multiply or this and that. Okay, so you can cross multiply here. Sorry, that's 3 by 5, which is 15k is equal to 1 by 10, which is 10. So you can divide by 15 by 15. All right, so let's simplify further, see what you're going to have at the end. Cancel this part, so our k is going to be by 5, that's 2, by 5, that's 3. So it's going to be 2 over 3. So that's the value of k. So with this part, I think it's pretty clear, and we can just work from there. It's actually pretty clear there. Okay, let us see the other part of the question. Now we are given on item 4, the area, express the area of triangle OAY as a fraction, okay, over this area of a trapezium OABC as a fraction in its simplest form. Okay, I want you to see what is happening. We need the ratio of the area. Okay, I'm just going to write this one. I have to explain it, so I'm just going to write it even here. I hope it's going to be clear, guys. I'm just going to write here so that I can explain this part properly. So the question is actually on item 5. We needed the area of a triangle OAY. So that was triangle OAY over the area of the trapezium. So that was the trapezium. Is it a trapezium or a parallel? No, a parallelogram. So this is a parallelogram, area of a parallelogram. So it's area of a parallelogram. Okay, I hope we've got good spelling there. Or ABC. Okay, so that was the question. Area of the triangle OAY. Guys, I want you to understand this part. Okay, this is your triangle here. O to A to Y. This is the triangle here. Okay, so these two, I want you to understand, guys, very, very much, because this person, you can use what you already know about the shapes that you're given. Okay, we are talking about area, and OAY, we are not sure it's a right angle, it's not, but we can see that it's a non-right angle triangle, this one. And area of a triangle, we know that it is used, we use this formula, half AB sine theta. Okay. Then a parallelogram, we know that the area of a parallelogram is AB sine theta also. So, sorry, guys, sorry for this. I don't know what happened. So what you're going to have here, guys, is that from the sine theta that you're having here, it's actually the same thing, or the same value here. This sine theta, this sine is the same theta that you are referring to. So to take advantage of this sine theta, you are going to take this sine A as your theta, because A is being shared by the parallelogram and by this triangle A, this angle A here. It is being shared by these two shapes. So which means I'm going to take my A as the sine theta. And I'm going to use the sides now. From O to A, I've got 4P, okay? From A to Y, I have this one, because remember AY, we wrote our AY here, and we said AY is equal to 5K cube. So which means we can find this, since we have the value of K now, it means AY is equal to 5 times K. Our K that we obtained previously, what was that K? Let us cross check here. Our K here, it was 2 over 3. Okay, that's 2 over 3. So we are going to multiply to K, which is 2 over 3. Okay, so it's going to be 2 over 3 times vector Q. Okay, so times vector Q. So if you multiply this, it's going to give you 10 over 3 vector q, like this. Okay, so that means we have got AY, which is 10 over 3 vector q. So this is 10 over 3 vector q, like this, 10 over 3 vector q. Okay, let me just save this a little bit. Okay, so it's 10 over 3 vector q. This is our AY, this one, which is with this side here. Okay, so we say these two, they share the same angle A, which is our theta. Okay, but remember that the whole of AB, we have it because this one we said is same as this one, the whole of AB from A to B. Remember, we said this one before, it's 5Q. So we've got 5Q here. Okay, so for the triangle, this is what I'm going to do because I need the area of the triangle OAY. So this is OA to Y here. So the area we said is half AB sine theta. So our area is going to be half times A and B. These are the sides which are creating the angle theta, the angle that is in between. So this is your A and B, these sides. We're talking about vector 4P and vector 10 over 3Q. These are the sides that we're talking about. Okay, so we're going to multiply times 4P times 10 over 3 vector Q times sine theta now, which is our theta is this angle that these two are sharing, which is angle A. So it's going to be times sine A. I want you to see what is going to happen later on, times sine A, like this. Okay, everything over what? The area of the parallelogram OABC, which is this whole shape now, the parallelogram OABC, the whole of this shape. But now you can choose any angle, but now because of the angle that we are talking about A, we can't choose any angle, we have to work with this A. So remember we said our area of a parallelogram is AB sine theta. So it's just 4P, this is your A, this side, and this side of 5Q. So it's 4P times 5Q. So this is what you're going to have because you've got AB sine theta. So it's 4P times 5Q times sine theta. Our theta is the common angle, which is A. So from this, we can obtain the ratio of these areas because all these that we see, they can cancel each other, guys. The 4P can cancel, the Q can cancel, the sine A can cancel because they are the same. So here we can also cancel 2 into 2, that's 1, 2 into 10, which is 5. So we're going to remain with 5 over 3 divided by this 5. So it's going to be divided by 5. Okay, so divide by 5, sorry. So that is the area actual, or you can write it like this, 5 over 3 like this over 5. Okay, so from a calculator, you can simplify 5 over 3, whatever that we get here, we divide to 5. Our answer is going to be 1 over 3. So this is the ratio of area of the triangle to the area of the parallelogram, just like that. So as you can see, guys, you must understand the concept. You must understand the concept of the question that you are given. Anyways, that was actually the idea of the question that we had here. I don't know if it is going to be clear, but as we are going to be working with different question papers and so forth, you are going to understand this concept actually. But that's the way that you can work in an easier way. Yes, you can use ratios, this and that, but it's going to give us a lot of things there. Okay, anyways, on number 9, we are now given answer the whole of this question on a sheet of graph paper. All right, so there, guys, we're supposed to calculate the value of P and the value of Q. So what I'm simply doing, we are simply substituting in place of X, we substitute 2 here. So Y is going to be 2 plus 5 over 2. With your calculator, guys, this is paper 2. So 2 plus 5 over 2, just like that on your calculator. You've got 9 over 2, which is 4,5. So that's where we're going to get our 4,5 here. And we move on to X. When X is 6, we substitute 6 is going to be 5 over 6. So it's going to be 2 plus 5 over 6. So this time it's going to be 5 over 6 like this, which is 2,8333 like that. But because of the other numbers that you're given, as you can see, these other numbers, they're rounded off to 1 decimal place, 1 decimal place, 1 decimal place. So we are going to round off this one to 1 decimal place. So it's 2,8 because these 3 cannot change this 8. So it's going to be 2,8. All right. So that's what we have here, 2,8. All right. Then from there, we are now given from this table using a scale of 2 centimeters to represent 1 unit on each axis. Draw the graph of this is the graph you are given from X is equal to 1 to 8. Okay, so we're going to work with this range that we are given of values of x, which is something like this, of this nature. So you just need to understand your scale. If this is 1, it means each box represents 0,1. So it's 0,1, 0,1, 0,2 up to 1, something like that. Okay, so that is your Cartesian plane. So all you need is to mark the points, guys, 1, 7, all these points that we are given. I think it can be much easier. Okay, so let us mark our points, 1 versus 7. So to reduce this graph some. Okay, we need to reduce again. 1, 7 is going to be somewhere here. When x is equal to 1, y is 7, which is somewhere here. All right, then we have got 2. That was in 4,5. So 2 versus 4,5. So 4,5 is simply in between 4 and what? 4 and 5. That's 4,5. Then we have got 3. It was 3 and what? Let's see. That was 3 and 3,7. So we remember I said each box represents 0,1. So this is around 3 here, and we need 3,7. So 3, this is 3,5 in between 3 and 4. That's 3,5. So 3,7, just count 2 boxes from 3,5, which is somewhere here. You count 2 boxes, you mark your point. Then we move on to 4 up to the last point. Okay, so it's 4 versus 3,3. So 3,3 just above 3. So this is 4, and this is our 3 here. So 3,3, we count 3 boxes from that 3. 1, 2, 3. This is our 3,3 here. Mark a point, just put a plus there, or just an X, whatever that you're going to do to mark a point. 5 versus 3. So it's going to be 5 versus 3. 5 versus 3 here. This is our 3. So we're going to mark a point, 5 versus 3. All right, then we move on to 6. So it's 6 now versus that value of Q, which is 2,8. Okay, so this is 6 versus 2,8. 6 versus 2,8. So 2,8 is just above 2. Okay, 2,5 in between 2 and 3. This is 2,5. 2,6, 2,7, 2,8. So it's 3 boxes above 2,5. All right, then we've got 7 versus 2,7, okay, which is just 1 box from that one that we had. So it's 7 and just 1 box from that one that we had. And the same thing with 8, because it's going to be 2,6, just 1 box below the 2,7. So it's 8 here versus 2,6, just 1 box below the one that we have there. Okay, so these are the points, guys. This is an inverse graph that we know because the x is in the denominator, so it's an inverse graph. So we just join the points as usual. Okay, so here the joining part, guys, make sure that you draw a smooth curve. As for me, guys, it's going to be difficult, but make sure that you draw a smooth curve. All right, guys, yes, not going to be that smooth, but make sure you try by all means to draw a smooth curve. Right, just gonna remove that a little bit here. All right, guys, not smooth, but it looks like this. Okay, so it's gonna look like this, but yours has to be smooth, guys. So you can use those refills. I don't know, a ruler, those rulers that you can actually, if you can bend that ruler to a nicer way, you can use it. But as for me, guys, as you can see, that's what I'm having. Okay, anyways, after that, you write down the equation of the graph. Remember, your graph was 2 plus 5 over x. That was the equation of the graph that you had. So that is what it was going to look like. And let's see the questions now from the graph. From this graph that we are talking about, the question is, use the graph to estimate. So which means because they know you're not going to have something that is that smooth, that is why they are saying you must estimate, which means it's not accurate. Okay, the gradient of the graph at 2 plus 5 over x when x is equal to 2. So it's simply the gradient. Remember gradient, guys, I told you where x is equal to 2, you have to draw a tangent, then you can take 2 points from there. So this is x is equal to 2 to the graph. At this point, you draw a tangent at this point, which is 2 versus 4,5. Okay, so let us reduce our ruler a little bit. Okay, so it's very, very long. Okay, let me reduce this ruler so that we can just draw our suitable tangent. So make sure that you just draw a line at least 3 centimeters from that point like this. The tangent just touches the curve. It doesn't, like, you don't draw inside of the curve. It must just touch the curve. Okay. Then you can join, so something like that. Okay, so here, like I said, it's not going to be that accurate, but that's what you're supposed to have. Okay, guys, what happened here? You need to remove this part. Okay, something like this. Okay, so this is your tangent, guys. From the tangent that you have, you're going to take 2 points from this tangent. Okay, and the first point that you're going to take is the one that you're already given, where x is equal to 2. That's the first point that you're going to take, where x is equal to 2, y is equal to 4. Or you can even go to the table here, cross-check on your table here. When x is equal to 2, already the value is there. 2 is 4,5. So this one, make sure it's your reference point. Okay, so you've got 2 versus 4,5. So I'm just going to write it maybe aside here. So we said this was item, what item? Which item is it? Can I cross-check the item? So this is C item 1. Okay, so that's C item 1. So you could see item 1 here. So you need the gradient. Okay, so you say the first point is 2 versus 4,5. So this is our first point. And we choose the second point. So the second point you're just going to take anyway, as long it is on the line. The point that you're supposed to take is supposed to be on this line. Okay, so here, just like if I am to take from the line that I'm having, maybe you're taking 3, or you're taking any point. Okay, so maybe it's 2, whatever point. Okay, so here actually we take any points, 2 versus whatever point that you're going to have from that part. Okay, this tangent of mine, guys. Okay, 2 versus 3,5 according to my tangent here. 2 is corresponding with this point is 4,5. No, not 2. 2 is the one that we have. So I'm going to take 3. Okay, 3 corresponds with this point, which is 3,5. But guys, it's not, I don't know, but you have to take exactly what is supposed to be, but according to your line there. Okay, but actually the actual point that I was having on my actual graph was 3 and 3,5, 3 and 3,25. That was the actual point that I was having, but you take according to your graph. Okay, so this one you take according to your graph. So you've got x1, y1, x2, y2. So how do you find gradient? Remember, gradient is the increase in y over the increase in x. So it's y2 minus y1 over x2 minus x1, whereby y2 is 3,25. So 3,25 minus y1, which is 4,5, everything over x2 minus x1. So our x2 is 3 minus 2. So this is what you're going to have. So you can even use your calculator direct, guys, to simplify this. You're going to obtain something like negative 1,25. All right, so that was our gradient for this question. Let us check the other question that we were given from this graph that we had. All right. We are now given from this graph that we have item 2 part. Calculate the area enclosed by the graph. Take note the graph, which is the same graph that we had, which is this one. As you can see, it never changed. X is equal to 1, X is equal to 2, and the x-axis. So which means we need a region which is bounded by these lines. Okay, this is what I'm trying to say. This is your graph here. We have to draw the line of x is equal to 1. Okay, so x is equal to 1. You use your ruler. Okay, you use your ruler, but okay, let me just insert the ruler. This one is just a vertical line, so it's not going to take us much time. So you use the ruler to draw those lines, okay? Just like what we did on the previous part, okay? So that's our ruler here. You need it to be upright. So I'm just gonna put 270 like this, okay? So at x is equal to 1 here, that is where x is equal to 1, you draw a straight line to mark that boundary here. So this is your x is equal to 1. We draw like this, that's our boundary. For x is equal to 1. So we've got x is equal to 1. X is equal to 2. We do the same. We move on to 2 here. This is your x is equal to 2. You draw a line of x is equal to 2. You write even the equation x is equal to 2. So this is the region because it's bounded by the graph the line of x is equal to 1, x is equal to 2, and the x-axis, so which means we are left with this region, this one. This is the region that you are left with. Okay, you are not supposed to share this region. I'm just showing you this is the region that you are left with. So what are you going to do? You count all these boxes that are in this region. You count those boxes. That is your area, because remember, guys, I told you that the area of a graph from a quadratic is going to be number of boxes over, so this is actually item 2, so our area is going to be number of boxes over 100 times the area of unit square. So times area of the unit square. Okay, so we've got the unity square in this case. Okay, so that means we are going to have the number of boxes. You calculate them. So in this case, I calculated mine from a separate graph. I got something like 562 or 563. I don't know from yours, but whatever that you're going to get over 100 times the area of the unit square. Remember, guys, I told you that the unit square is the first box that you have on your graph here. This box that you're having here, we are given on this side, our y is 1, our x is 1. This is the box that we are referring as the unit square, the first box, this one. So x is 1 here, y is 1. So 1 times 1, that is 1. That is the area of the box. You multiply those units. Okay, so 1 times 1 gives us 1. So you're going to multiply by 1 in this case. Okay, so you're going to obtain something like 5.62 square units. So area is measured in square units, or you can write it as 5.62 square units like this. Okay, so that is how you simply calculate the area, guys. Just like that, you're done. Let us see the other part of the question from this graph that we are given. Okay, so this is the last part of the graph. On the same axis, take note, guys, on the same axis, draw the graph of y is equal to x. Okay, so y is equal to x. Remember, you can use table values, or you can use any method to draw this line. It's actually there. But if you are to cross-check, if we say y is equal to x, it means these two, they're actually the same. So for any value of x that I have is the same as the value of what? As the value of y. So if x is 1, y is 1. If x is 2, y is 2. 3 is just like that. So it means points, they correspond to each other. That is what it means when y is equal to x. So you can say when x is 1 here, when x is 1, y is 1. When x is 2, y is 2 here. When x is 3, y is 3 here. Okay, so these points are actually enough for us to draw this line. So all you need is to join the points that you are given. I think it can help us. All right, so I'm just going to put somewhere here. I just hope these points, guys, I'm still far. Okay, let me change something like this. Okay. All right, so I just hope they are going to meet. Okay, something like this, exactly. So now what you do, you join these points, you have your line of y is equal to what? Y is equal to x. Okay, so this is the line of y is equal to x. So the first question was for you to just draw that line. That is, answer the question, guys. Draw the line. You have drawn your line. Then from this line, what are we supposed to do? Okay, and solve from that line that you have solved. What is happening here? If you are to cross-check the 2 plus 5 over x, this part here is representing the value of y. Previously, we are given our equation here as y is equal to 2 plus 5 over x. So in place of 2 plus 5 over x, we are now replacing with y here. This is what happened. So it means these two, they are equal. The graph of y is equal to 2 plus 5 over x that we had before, and y, which is equal to x. These two graphs, they are equal. So where are they equal? At the point of intersection. Where these two graphs meet, that is the point of what? Intersection. Where the graphs meet, that is the point of intersection. So at the point of intersection, that is where your answer is going to be taken from. Okay, so this is our point of intersection of the two graphs here. As you can see, the inverse graph and the straight line, they meet at this point. Where these two meet, at that point, we draw using a ruler, dotted lines straight to the x-axis. Okay, so you're going to use your ruler straight to the x-axis. That is where the value of x is going to be. So according to my graph, it's 3,5 in between 3 and 4, which is 3,5. So that is the value of x that I am having when y is equal, when this graph is equal to x. So this was item D. So we are now writing x is equal to 3,5. You are writing the solution, the value of x. So if it was a quadratic graph, sometimes they can meet at 2 points like this, which means we are going to have 2 values of x. But here they're just meeting at 1 point. So that is why we just have 1 value of x. Okay, so that was the idea of the question. I hope it was clear. Let us see the question 10. From question 10, solve the equation. That's a quadratic equation. So as you know, guys, your quadratic equation, you have to use the quadratic formula. Okay, sorry, I wanted to mark first. Okay, you have to use your quadratic formula. So this equation, we are given 2x squared minus 4x minus 3 is equal to 0. So using our quadratic formula, we know that x is equal to minus b plus or minus the square root of b squared minus 4ac, everything over 2a. Okay, so all you need is to substitute the values of a, b, and c. So our a in this case, that's the coefficient of x squared, which is 2, because our equation has to be ax squared plus bx plus c is equal to 0. So a is 2, our b is -4, our c is -3. So you can substitute into the formula. So we are going to have minus b, which is -4. So it's minus 4 plus or minus the square root of b squared, which is -4 squared minus 4a. Our a is 2, so we multiply, times c. Our c is -3, so we multiply. Okay, everything over 2 times a, which is 2. So from there, guys, we know that negative and negative gives us a plus. So it's going to be 4 plus or minus the square root of. So this is what I wanted to do. You simplify this part under the square root, but do not put the square root, just this part under the square. So this is what you're simply doing. Minus 4 like this in a bracket, squared minus 4 times 2 times -3. Okay, so you're going to obtain 40. Okay, so it's going to be square root of 40 here over 2 times 2, which is 4. Okay, now from this part, as you can see, guys, we can separate because we're now having a single number under the square root. So we can separate to say our x is going to be 4 plus the square root of 40 over 4, or another x is going to be 4 minus, because we've got a plus or minus here. So we started with plus, so this one is a minus. Square root of 40 over 4. So from this part, guys, it's now you and your calculator. Make sure you insert your values properly here. So put in your division. Okay, that's gonna be 4 plus square root of 40. Okay, whatever that you're going to have here, you divide by 2. That's your answer. Okay, so you can put it as a fraction or as a decimal like this. It's 2,58, something like that. Okay, most of you guys, you use DAL. So if you're using DAL, you assist your calculator because your calculator does not know all these fractions. Okay, so this is what you do. You open a bracket. You're going to evaluate 4 plus square root of 40 like this. So you're going to put square root of 40. You close that bracket after you're done. Then you put the division then by 4 like that. Okay, you can get the same answer just like what we have 2, something. So this is what you do if you're using DAL. But if you're using Casio, there's no need. You have to put that fraction as it was. Okay, so the first x is going to give us 2,5811, something like that. Or x is equal to, we move on to the minus, so you just have to put a minus there. So you're just going to move, delete that and put a minus, which is going to be negative 0,58, something like that. All right, so 1, something like that. Okay, so let us check the degree of accuracy we are given. Giving your answer to 1 decimal place. Here we are given an instruction, so we follow the instruction that we're given to 1 decimal place. Okay, so to 1 decimal place, that means if I'm to round off, I'm going to get x is equal to 2, this is the first digit after the comma, so 8 is going to change this 5 into 6, or x is going to be negative 0, this 8 is going to change this 5 into 6. So that these are the values of x that I'm going to have from this one. Okay, so guys, as you can see, it was pretty clear. So let us cross-check another part of the question and see what you're given. Now I've got a part of bearing. Okay, so I'm just going to clear this so that we can use this space. Okay, sorry for that. Okay, sorry for that, guys. I'm supposed to do this. Okay, so this is what we are given now. That is from our diagram. We've got The diagram shows 3 points P, Q, R, which are on level ground. SR is 4 kilometers, so we've got 4 kilometers. Then the bearing here of P is north 56 degrees. That is this P here from T, north 56 degrees to the east. So this is a compass bearing, as you can see, that's a compass bearing. So it means we are going to have like a continuation, something like this, something like that. Okay, then the bearing of R, that is R is south 60 degrees east. So from T, it's south 60 degrees to east. Okay, so that's what you have. And P is due north of R. P is, which means this is a north pole that we see here at P. This is a continuation of a north pole that is at P, and it goes, it's due north. So it's a continuation on the north pole. So that is what they're trying to say. Okay, so that is what we have. Then the first question is calculate the shortest distance between line PR and T. Remember, guys, what I talked about, the shortest distance. I said this is the distance that you take from the point T to line PR. This is your point T here to line. So it's a distance that is going to meet this line PR at 90 degrees. Not to say it is going to bisect, and no, it's not going to bisect anything, but it is going to meet this line at 90 degrees. So this is the distance that we need to calculate, this height. If we can have this height, then we are having the shortest distance. So what are you going to do? We know that if this is 90 degrees, definitely this side is also 90 degrees, okay? Remember, we said this is a north pole here that we have from P to R, it's a north pole. So if it is a north pole, it means these two lines, they're actually parallel to each other. And by being parallel, it means if this angle is T is 60 degrees, this angle R is going to be 60 degrees because we are forming a Z there. So that's 60 degrees. So I have advantage because I've got this side of 4 kilometers and it's a right angle triangle. So which means I'm going to apply the trigonometrical ratios. Why? Because I'm given an angle inside this triangle. So using trig ratios, what do we have? This 60 degrees, according to 60, this side X is the opposite. Okay, the 4 kilometers that we are given is opposite to 90 degrees. That makes it to be the hypotenuse. Which ratio uses opposite and hypotenuse at the same time? That is the question now. That is for Sine from your soccer tour. All right, so we've got our soccer tour there. Sine is opposite over hypotenuse. So sine theta is equivalent to opposite over hypotenuse, which means sine of the angle that I'm given 60 degrees is equal to the opposite, which is the shortest distance that we want to calculate over the hypotenuse, which is the 4 kilometers. So to find X, I'm just going to simply cross multiply. 1 times X is equal to 4 times sine 60. That's 4 sine 60. So X is equivalent to 4 sine 60. I just need a calculator here for sine 60 degrees. That's going to be something like 3,46, something like that. 3,46. Let me check the answer again. 464, something like that. Okay, so you write everything up to the end. So here we are not given the degree of accuracy. So whenever we are not given this degree of accuracy, what do? You round off to 3 significant figures. So 1, 2, 3. This 4 cannot change this 6. So it is going to remain as 3,46 kilometers. Remember the units that we are given for its kilometers. So your answer is going to be in kilometers. So that is the shortest distance that you're given here. Okay. Anyways, let us move on to the other question. Calculate PR. This time we want to calculate the distance from P to R. Okay, that is PR here from P to point R here. Okay, so what are you going to do? There are so many ways that you can use actually. Here you can apply the sine rule. Remember, guys, this is a straight line here. So I'm just going to remove this part like we never did this. Okay, so maybe, are we going to use this? Okay, if we are to need this, I have it aside because I need to make this page clean again. Okay, remember we're saying these are parallel lines and we are given this angle. This angle is already there. We say this angle is 60 degrees. Okay, this is what I want you to see. This is a straight line. We've got 56 and 60 degrees. So you can calculate this angle that is remaining inside this triangle because angles in a triangle, they have 180 degrees. So 180 minus the sum of these two, 56 plus 60 degrees. What are you going to have at the end? We can have something like 64 degrees, if I'm not mistaken. So this is 64 degrees, okay? So if this angle is 64 degrees and this angle is 60 degrees, we can actually find the angle at P here because angles in a triangle add up to 180. So I'm going to subtract. That one was angles on a straight line, not angles in a triangle, but this one is angles in a triangle. Sorry if I don't know what I said before, but I think I mistakenly said it. Okay, so it's 64 degrees plus 60 degrees now. If we subtract this, we're going to obtain something like 56 degrees. Okay, so this angle here will be 56 degrees. That means we are now able to calculate PR because this PR here corresponds with 64 degrees, okay? And we are given 4, which corresponds with 56 degrees. And I told you guys on this condition, the best way to use is the sine rule. What does the sine rule say to calculate a side, okay? We know that our sine rule to calculate a side is going to be A over sine A, which is equal to B over sine B. So the A is the side that you're calculating. So you're calculating PR here. So it's going to be PR over the corresponding angle sine A, which is the sine of this angle, which is sine 64 degrees, is equal to B over sine B. So B is what you're given, which is complete now. The 4, which corresponds with 56. So it's 4 over sine 56 degrees. Okay, so how do I solve for PR? Yes, I can cross multiply this and that. Okay, it's fine. We can do that. Cross multiply here. That's PR times sine 56 degrees, which is equal to 4 times sine 64 is 4 sine 64 degrees. So to find the PR, I'm going to divide by sine 56 degrees here. All right, divide by sine 56 degrees here. So this can cancel. So PR is equal to the whole of this part here. So I'm just going to use my calculator to simplify this. So if you are using DAL, you open a bracket, you write this 4 sine 64, okay? 4 sine 64 degrees, so it's going to open a bracket again. Then you divide by sine 56. So now it's only that here. If I use sine, it automatically opens the bracket, okay? So I don't know if it's gonna be clear. So it's going to be 4,333, something like that. Okay, 336, 5, something like that. Okay, so our PR is going to be to 3SF, 1, 2, 3. So the 6 is going to change this 3 into 4. So it's going to be 4,34 kilometers. Okay, so that is your PR in this case. I think it was pretty clear. So it's a matter of also understanding, guys, the concept that you are given from that part that you have. Okay, anyways, let us see the other part here that you are given. From an aeroplane flying directly above T, the angle of depression of R is 20,3. Okay, guys, this is what is happening. There is an aeroplane which is flying directly above the point T. Okay, this is our point T here. So the angle of elevation, remember the angle of elevation, you are looking down from what you have. This is, we are having at the top here at T. This is where the aeroplane is flying directly at T. So what you're going to see is that this angle that we are having from T, we are looking down, that is to point R here. Okay, let me get my question back here so that I can understand together. That is the angle of depression of R is 20,3. Calculate the height of the aeroplane above the ground of T, above the ground of T. That is what is happening here. So we need above the ground of T. Okay, so this is what is going to happen here. This is our point R, not point T, guys. This one is point R that we are given, which is the angle of depression is 20,3. So we actually need an angle of depression. So as you know, guys, that we are supposed to look at the ground at this point at 20,3. Okay, let me erase this part. This was supposed to happen here. The aeroplane is on top of what is on top at what? At T here. And we are looking down to R. So we are supposed to look down through this angle here of what? Of 20,3. But we know that this angle, we are looking at the ground where R is on the ground. So R on the ground is actually a horizontal line. And this T going down to the ground is a vertical line, and it meets this line at 90 degrees. That is what is going to happen. And because these two lines here, they will never meet. They are vertical line, they never meet. This will make them parallel. So this 20,3 is going to be written here as 20,3 degrees. So the question that we are given is to calculate here the height of the aeroplane above the ground of T. So this is what you're going to see above the ground of T. What is the aeroplane that you're going to have, this distance? So you can just put this as H. So according to this ratio, since it is a right angle triangle, we can apply trigonometrical ratios, guys. This is item 3 actually. So you can apply your trigonometrical ratios. Since we have 20,3, this is opposite, and this is hypotenuse, guys. This ratio you've used a long time, or you can use the 60. So you're going to have, in this case, but it's not going to be like directly the way that it looks like on my diagram, guys. It's going to be on another part there. Okay, so this 60 is going to affect us actually. Okay, but you're going to have something like sine, is it opposite? Okay, guys, I think this information is actually doesn't tally because our angle was supposed to be on the top. So I'm going to place this on the top part. All right, so guys, let us just do this. I hope it's because of this one. Okay, so you're supposed to work with this one. We can actually work with this one here. But it's going to give us the same thing because this one will be opposite, and we're working the 4,3 that we had before. So guys, this one does not affect, it's going to be the same. Okay, anyways, I hope it's going to be the same. So let me know, guys, on the comment section what you're actually seeing there. Sine theta is going to be opposite over the hypotenuse in this case, which is sine of 20,3 degrees is going to be opposite, which is this h, over the hypotenuse, which is 4. So you can cross multiply here. Okay, by 4. So this can cancel. So h is equal to 4 sine 20,3. Okay, so let us see what our h is going to be. 4 sine 20,3. Okay, so 4 sine 20,3 like this. Okay, so this is what you're going to get. 1,38, something like that. Okay, 1,38. Okay, let me see here, 387. So the 7 can change, this 7 can change this into 9. So it's going to be 1,39 kilometers. Okay, so guys, let us cross-check again on this question. I'll just cross-check on it so that we can talk about if there is any mistake. I'm just going to look after this so that we can actually work on it separately if there can be any other mistake. Okay. Number 11, you're given the sum of interior angles of a polygon. This is a polygon that you're given. We do not know is a regular or is an irregular. That part does not matter. We are not told about that. It's just a polygon. Okay, we are given the sum. And from this sum, 3 of its interior angles, these are 3. The rest are equal. Okay, so which polygon is this? Find the size of the equal angles. Okay, so the first thing is for us to know how many sides does this polygon has, so that we can know actually how many angles does it have, because you are just given that the rest are equal. How many are they? We do not know the rest of the angles, but we are just told they're equal. Okay, so from the sum of interior angles, we know that we can use this concept. N minus 2 times 180 gives us the sum of interior angles, and we are given the sum. So you can find n, the number of sides, which means we know the number of angles. Okay, so it's going to be n minus 2 times 180 degrees is equal to 3,240 degrees, which is the sum here. So you can divide by 180 degrees. We can divide by 180 degrees. So n minus 2 is equal to, if we divide this, what are you going to have? Let us put this aside here. Okay, so we've got 3,240 divide by 180 here, which is going to give us something like 18. So which means n is equal to 18 plus 2, which is our n is 20. Okay, so this polygon has got 20 sides. But that is not the concept. Here we are told that 3 of its angles are given. These are 3 angles that you're given. Okay, the 3 angles, we are given these 3 angles. So which means how many are the rest, which means the remaining one? From 20, we have taken 3. So it's going to be 20 minus 3, which is going to give us 17. So which means these remaining angles, they are 17 and they are all equal. So if each angle is x, which means all of them, they're going to be 17 times x. Okay, so we can write this in terms of x. So it means if I am to add these interior angles that I'm having, I'm supposed to obtain 3,240. So this is what I'm going to do. I'm going to add the 3 angles that I'm given. Let us add it here. We can even add here, guys, because of the space that we are having. Let me just remove this part. So it means if we add these, they must give us that total of what? 3,240. So let us add these angles. 140. Okay, I forgot to put this. So it's going to be 140 degrees plus 110 degrees plus 100 degrees plus those angles which are the same, which is 17x. We must obtain a total of 3,240 degrees. By doing this, guys, it's going to help us now to find the value of x, because x is that angle, those angles which are equal. So that is what we are simply having by calculating x. So what you need to do, add these together. We can get something like 350, if I'm not mistaken here, 350 plus 17x is equal to 3,240. So you can transpose the 350 to the right-hand side, is going to be a negative. So 3,250 minus 3,240 minus 350. Okay, so you're going to obtain 2,890. Divide by 17 both sides, by 17 both sides, we can have the value of x. That makes it to be the angle that we are looking for, which is 170 degrees. So each angle here that we are talking about is 170 degrees. Okay, so that was the concept of the question, guys. I hope we understand what it was about. Okay, on B, we are given that there are 40 people who took a race on this part. Okay, the distances to the nearest meter that they covered in a certain interval are given in the frequency table below. Okay, so this is the table that we are given. Remember, there are 40 of them. So if we add 4 plus 6 plus everything, we must get 40. Okay, so the question is item 1, state the model class. So remember, the model class is the one that is got highest frequency. So we need on the frequency, you must be on the frequency here. Which one is got the highest frequency? The highest frequency is what? 18. So the class is the answer, which corresponds, which is 70 less than or equal to x less than 80. That is our class. Okay. Then on item 2, if the information is to be, guys, understand the question. If this, they never say draw a histogram, but if this information was drawn on a histogram, what are the values of P, Q, R? Let's say a histogram is there. What are the values of P, Q, and R? The P, the Q, the R is what? These are the frequency densities. So they are simply saying calculate the frequency density, full stop. That is what you're simply having here. Okay, so remember your frequency density, guys. I told you on the histogram, we did the histogram last time. I told you that on the histogram, the frequency density is equal to the frequency over the class width, which is how the class is big from the lower class to the upper class. Okay, so the frequency density is the one that you're calculating. So when you're calculating P, you're calculating the frequency density. So P, which is our frequency density, is the frequency over the class width. So according to P, what is the frequency here? The frequency is 6. Over the class width, how big is this class that corresponds with P? From 20 to 50, how big is this class? So you're simply subtracting 50 minus 20. That is upper class minus the lower class. So it's 50 minus 20, which is 30. So you're going to divide this by what? By 30 here. Okay, so on your calculator, we are going to obtain 0.2. You do the same on Q. So Q is going to be the same, the frequency over the class width. As you can see, Q is the frequency density again. So the frequency is 4 over the class width from 60 to 70. How big is the class? So it's 70 minus 60, which is 10. So it's over 10, which is going to give us 0.4. On R, you do the same again. This is your R here. So you're going to have your R as the frequency there, which is 13 over the class width from 70 to 80, we've got 80 minus 70, which is 10. So we're going to divide by 10, which is 1,3. Okay, so that is what we're going to have there as the value of what? As the value of R. Okay, so these are the values, guys. Item 3, calculate the mean distance traveled, the mean distance covered, okay? So remember, guys, the mean, you actually need the class centers. So here, we are going to work with the class centers and the frequency. Remember how you calculate your mean, guys. I talked about this before. Okay, so this is our item 3. So you calculate the class center for each class, you multiply to the frequency up to the last one. Okay, class center times frequency over the total frequency. So we are saying the class center, remember class center, we are adding, the class center, we are adding the lower class to the upper class, whatever that we get, we divide by 2. So this is what I'm simply doing. This is your lower class. The first class is 10 plus 20 divided. So guys, this is what you simply do on your calculator like this. You put a fraction or you put a bracket like this. Okay, then you add inside the bracket. This is what you're going to write: 10 plus what? 10 plus 20. 10 plus 20 like this. You close the bracket, you divide by 2 like this. You're going to get 15. Okay, so that's what you do for all these classes. So 15 times the frequency. Now the frequency is 4, so it's 15 times 4. So you're going to have 15 by 4 here, plus you move on to the second class just like that, guys, up to the last class. So here you add again 20 to 50, which is going to give you 35. You do this properly, times the frequency, which is 6. So it's 35 times 6. So it's going to be 35 times 6. Plus, we move on to the other one of 50 to 60. You do the same again. This one is going to give you 55 times 8. So it's 55 times the frequency, which is 8. 55 times 8. Plus the other one, just like what we did, guys, 60 to 70, which is 65. Yeah, that is 65 times 4. So it's going to be 65 times 4 here. 65 times 4. You move on to the other class of 70 to 80, which is 75. 75 times 13, just like that. Okay, so it's 75 times the frequency, which is 13. Okay, so times 13. Plus, you move on to the last class, which is from 80 to 100, which is going to give you 90 times 5. So this will be 90 times 5, just like that. 90 by 5. So everything, that's your mean. Okay, so mean is equal to this over the total frequency. So we are not calculating again because we are given the frequency before to say 40 people took this. So which means everything here is out of 40. So you're going to divide by 40, whatever that you're going to get here. So that's it, guys, about the mean. So this mean is going to be, you multiply here, you're going to get 60 plus 210 plus 440, multiply 65 by 4, which is going to be 260. So you add everything up to the last one, 260, plus the other one is going to give us 975, plus the other one 450. Okay, everything over what? Everything over 40. I just hope I'm not mistaken anyway. Okay, so everything over 40 here, that means we are going to have a total of 2,395 over 40. Okay, so if we are to simplify this, it's going to be 59,875 meters. Remember, this was distance, so this is the mean distance in meters. Okay, so pretty clear. You just have to work on more questions, guys, to understand these questions much more. Okay, then on item 4, we are now given that there are two peoples which were being picked here or being selected at random to make a report on the rest, like what happened. Find the probability that both, we are talking about those people that they both covered 70 meters or more in the race. So we need where there is 70 meters or more. This is where we need our answer. 70 meters or more. So let us get back to the information. Where do we have 70 or more? If we are to cross-check on our diagram here, we have got 70 or more here, where it's x, it's greater than or equal to 70 from this. This one is x is less than, but more, x is greater than or equal to 70. So we need from 70 up to the last one, that is more. So we're going to add these in this region, which is 13 and this 5. So 13 plus 5, that's 18. So we have 18 pupils or 18 students who are 18, who are more than what? Who covered more than 7. Those, there were 18 of them who were there. Okay, so since we picked 2 students, the first one that we pick is going to be 18 over the total. Remember, our total was 40. But the moment we pick the second one, it means out of 17, we have taken 1 student. So we're now remaining with 17 of them. Also, the total is going to be affected. There were 40 of them. Now they are 39. Just like that. So that is the information, guys. From your calculator, you can simplify. This is going to give us something like 51 over 260, if I'm not mistaken. Let's just confirm with our calculator here. Let's hope it's not going to open Skype because I pressed that Skype button by mistake. Okay, so it's going to be 18 over 40 here, multiplied by 17 over 39, 17 over 39 like this. Okay, so it's going to be 51 over 260. So this is 50. Okay, we already have the answer. Sorry, I just wanted to confirm. So which means our answer is fine, 51 over 260. All right, so that's how you simply work out these questions. As you can see, guys, it was a direct question, no diagram, no. So guys, answer the question. Do not just rush when you read to understand the question. If does not mean draw. If is like an assumption to say, let's say it was there, what were you going to do? Okay, anyways, that's what we had. On number 12, we are given answer all of these questions on a sheet of graph paper. Again, we are given NOMSA. A newspaper vendor orders and sells 2 types of newspapers, the messenger and the arrival. So these are the 2 types of newspapers that NOMSA is what? Ordering and selling. Okay, so the first part, NOMSA always orders at most 100 newspapers for resale daily. That is at most 100, like all the newspapers combined, the arrival and the messenger. Okay, if X is the number of the messenger and Y the number of the arrival. So this is where you're going to start. Sorry for that, guys. Okay, so we're going to start by that. X, that is the messenger, okay? So we are talking about the messenger here. Then our Y, we are talking about the arrival. All right, so this is what you're given. So in this case, we are given that write down an inequality in X and Y that satisfies the given condition. Which condition are we given? This condition to say that she has to order at most. Remember, guys, I told you at most means less or equal to. So it means the newspaper for the arrival for the messenger plus the newspapers for the arrival combined together, they are not supposed to exceed 100. So they can be less than or they can be equal to 100, but they cannot exceed 100. That is what it means, okay? We move on to B. She always sells more than 20 copies of the messenger, okay? But the number of copies of the messenger sold does not exceed double the number of the copies of the arrival. Okay, let's start 1-1. Write down the 2 inequalities. Let us do it one by one. She sells more than 20 copies of the messenger. Messenger is X. So X is more. So they are saying it's more. So X is greater than, that is more. So more than 20. So more than, not equal to, just more than. So X is greater than what? 20, like that. Okay. Then here we are now, so the number of copies of the messenger, which is our messenger, it's X. Remember, messenger is X. This one does not exceed double, which means if it does not, which means it's less than the double of the arrival, and arrival is 2y, so it's less than 2y. So writing in terms of y, it means we can divide by 2 like this. So that means we are going to have x over 2 is less than y, or you can write as y is greater than x over 2. So you can write this inequality like this, or you can write it the way that it was, x is less than 2y like this. But this one is best for your representation on the diagram, but you can leave your answer like that. Okay, so x is less than, we are not, it's not supposed to exceed double. So it means it can be less than, or it can be equal to. So equal to there is there. Okay, so you can put equal to there, because not to exceed, guys, it can be equal to that one. It doesn't exceed it. What is not allowed is to exceed. So it can be less than or it can be equal to double the number of the arrival. Okay, so that is it. Then another part we are given here, by the end of each day, here we are given now, by the end of each day, she ends up having sold more copies of the messenger than the arrival. So the messenger, there are more. So this is our C now. So the messenger is X, it's more than for the arrival, which is Y. So writing this, we can see that X is greater than Y, which means Y is less than X. So you can write it as Y is less than X, still one and the same thing. Okay, so these are the inequalities that we are given from this part. So write down an inequality that satisfies this condition. We have written this inequality. Then D, using a scale of 2 centimeters to 20 copies, 20 newspapers, sorry, on each axis, draw the X and Y axis from 0 to 100. So 20 for each copy from 0 to 100. So that's what we have, the messenger on the X-axis, the arrival on the Y-axis. So all we need is now to represent, illustrate by shading the regions, that is the unwanted region. Okay, that must lie. So guys, let us start with the first one. Remember the first inequality we are given that X plus Y is less than 100. And I told you guys for that one is the easiest way is to use double intercept method. X plus Y is less than or equal to 100. So you can use double intercept because you're drawing the line of X plus Y is equal to 100. So double intercept, I told you you've got 2 points. We have got X and Y here, X and Y. So the first one, we are going to say when X is equal to 0, on the other one, when Y is equal to 0. So when X is equal to 0 here, Y is equal to 100. When Y is equal to 0 here, X is equal to what? X is equal to 100. So these are the 2 points that we're going to mark. 0 versus 100 and 100 versus 0. Okay, so we've got 0 here versus 100. That's 0, 100. At this point, you mark your point 0, 100 and 100, 0. You mark this. So remember, it was less than or equal to. So it means we have to draw a continuous line. In this case, this line just has to be continuous. All right, so this is what you're going to have, something like this. And this line must be continuous. Okay, so just like this, we are done. We've got your line. So remember, guys, what I told you about the inequalities, that this is less than actual. So let's write the equation first. X plus Y is equal to 100. Take note here, it was less than, X plus Y is less than, and our line is like this. And I told you this is the lesser side, this is the bigger side. So we need this side because X plus Y is less than 100. So we need this side, which is less than. Okay, so this is the side that we need. So which means we do not need the other side if we need this one. So we're going to shade the one that we do not need. That is what they mean when they say shade the unwanted region. Okay, so this is what you're going to do. We have shaded the unwanted region. We move on to the other one. It was X is greater than 20. So you just need to draw the line of X is equal to 20. X is greater than 20. We draw the line of X is equal to 20, which is a broken line because it's greater than. Okay, so where do we have X being 20 here? This is where our X is 20. So we actually need a broken line from that X, which is equal to 20 here. All right, so this is our X, which is equal to 20 from this one. We draw using a broken line. All right, so this is what you're going to have at the end using a broken line. So using a broken line means we do not take any point which is on that line. As long it is on that line, you cannot take that point which lies on a broken line, okay? So this is our X, which is equal to 20. You can write the equation of the line. X is equal to 20. But we are told that X is less than, as you can see, X, okay, X is greater than 20. That is what we are given. So we need the values which are more than 20 here. 20, 40, these are the values, 46, these are the values that we need. So which one do we not need? The ones which are less than on this side. So you shade the ones that you do not need. So we do not need the lesser side, this one. Okay, then we move on to the other one. It was X is less than or equal to 2Y. Remember the one that we had, that part where we had X is less than or equal to 2Y like this, where we said you can write it like 2Y is greater than or equal to X from that side like this. Okay, since we want to know which side to shade actually, or you can divide by 2, where we ended up with Y is greater than or equal to X over 2. So guys, this one you just need table values. As you can see, values of x and y. So you can just put any value. When x is equal to 0, y is 0. When x is equal to 40, that's 40 divided by 2, which is 20. When x is equal to 80, that's 80 divided by 2, which is 40. Okay, so you put 0, 0, 0, 0, that is this point, 0, 0. Then 40, it corresponds with 20, 80 corresponds with 40. Okay, so these are the points. Then you can draw. This one is a continuous line because it was less than or equal to. So it's going to be a continuous line, this one, all right, something of this nature. So these 3 points has to be in a straight line, actually. Okay, so let's just hope our points are all there in a straight line, then we can join. It's a continuous line because of the inequality. Okay, so take note, guys, we write the equation of the line x is equal to 2y or whatever that we had there, I don't know, or y, 2y is equal to x, I don't know what you're going to write, just write the equation. So which part are we going to shed? The part that you're going to shed must be determined with y not x, which means we have to take from y not from x. What am I trying to say? You have to take from here, from y. Remember, your line is like this. It's a slanted line, okay? You saw our line. It's a slanted line like this. We take it according to y. It's y is greater than x over 2. So we need the greater side. Remember, this is the bigger side. This is your greater. This is your lesser side. So here we need y, which is greater, which means we need this side, but we do not need this side, the lesser side. We are going to shed the lesser side, this one, which is on this below side. So that's how you work with it, this one. So we're going to shed this side. We do not need the lesser side. We are going to shed this side. So you compare with respect to y, not with respect to x, but with respect to y. Okay, then the last one, it was x is greater than 5. So since we compare with the y, let us rechange this in terms of y. So it means y is less than x. Okay, so here we simply draw the line of y is equal. Remember, y is equal, I explained about this line before. I said when x is 0, y is 0. When x is 10, y is 10. When x is 20, y is 20. So this one, we talked about this, if you still remember that line that we did in this same class. So 40 versus 40 here, 0 versus 0 here, 80. Versus 80, that's somewhere here. I'm just going to take, or even 60 and 60, because 80 is too far here. Okay, so you can join from the center to those points that we have talked about, these 3 points, okay, like this. So this one is a broken line. Remember, it was a greater than, so this one is going to be a broken line. So you draw a broken line there. So it's going to be broken, 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 broken. All right, so that's what we're going to have in this case. Okay, all right, okay, like this, okay? So you write down the equation of the line y is equal to x. And now let us see which part are we going to shed. Remember how our line looks like. It looks like this. This is what our line looks like. And we say this is the greater region, this is the lesser region. So I said you compare with y not x. We're using this to compare which side to shed. Y is less than x, which means we need the lesser region. So we do not need this bigger region. So we're going to shed the one that we do not need, okay? So this is what you're going to do. We're going to shed this region, which is above of the line, okay? So above of the line, y is equal to x, that's where we're going to shed. This is your y is equal to x, you shed this region here, you shed this region, you shed this region, okay? So as you can see, finally, there's a region which is left, which is not shaded at all, which is this region in between, which is not even shaded at all. So that is the one that you are going to take from. So I hope we understand this part. So that's what you simply need in this case. So guys, as you can see, that's what our diagram was going to look like. And this is the region that is remaining, the one that you're going to work with. Anything that you're going to have is going to be taken from this region. And you do not take anything from the broken line, which means you take from the continuous lines, from the boundaries of what? Of the diagram. Okay, so now because of the diagram, sometimes it might not be that clear actually the points that you're going to take, but those are the points that you're going to have. So the question now is, on item T, it is given that the messenger sells for $20 and the arrival sells for $80 per copy. NOMSA is given 2.5 commission on her sales. calculate the highest possible commission she could get. So guys, for her to get the highest commission, she must have the highest number of cells. So all you need is to pick a point in this region that is going to give us the highest number of cells. So like I'm saying, guys, you pick the points. Actually, this point, there are many, guys. So this is what you're going to have here. At the point of intersection, yes, something like 66, according to our scale. Remember, it's 2 boxes, 66. So it's something like 66 versus 33. This is 30 here. So 30, 32, 33. Okay. Then we have got 60 versus this point. 60 versus 40. It's actually at 40, this one. 60 versus 40. So there you pick those, but here you can't take anything. Here you can't take anything. Here you can't take anything. Here you can't take, because there's a broken line. So which means these are the 2 points that we can actually work with. This one of 60 versus 40, and this one for 66 versus 33. But as we can see, guys, 66 versus 33 is bigger than what? 60 versus 40. So I'm going to work with 66 versus what? 33. Okay, so when x is 66, y is 33. So you said 66 versus 33. Okay, so the point that let us see what we're going to have if we work the point 66 versus 33. So remember x, y, the x is the messenger. So the messenger is $20. So it's going to be $20 times 66 plus the arrival is y. So it's how many copies do we have? We sold 33 copies. So it's going to be 0.8 times 33. Okay, so if we add this, we are going to have $105.60. So this is the cost that like what she sold. She got something like 105.60. Therefore, what is the commission? Commission is 2.5% on her sales. So that means for us to have a commission now, we are going to say the commission from the highest amount that we got is going to be 2.5%, which is 2.5%. 2.5% is 2.5. So how do you remove percentage? You divide by 100. So it's 2.5 over 100 times now the money that she got, which is $105.60. Okay, so from your calculator, that is what you're going to have as your commission. So I don't know, you're going to have something like $2.64. This is the commission, the highest commission that we can ever get from this information that we had. Okay, so guys, that's what we had from this question paper. I think we understand all the concepts that we had there. All we need is to work on match question papers and revisions as we are working on our revisions. So that's it, guys, from Mason African Motives. Till we meet again.